Hello, my friend. I'm glad you found your way back here tonight. Settle in. Let your shoulders drop. Let the day soften away, because tonight we're stepping into something a little different from what we usually explore together. You have probably been told at some point in your life that we are the first creature on this planet to build something, to burn something, to leave a mark deep enough for the future to find one day. But what if that was never true? What if long before the first human breath someone else already stood here, rose and built and burned through the world in their own quiet way, then vanished so completely that we have spent 100 years walking straight past the evidence, never once suspecting it was there under our boots? That question has a name now. Scientists call it the Silurian Hypothesis, and tonight we're going to sit with it for a while, slowly, the way you sit with a question that refuses to let you fall asleep right away. Before we go any further, though, let me ask you for something small. If you find yourself enjoying where these stories tend to take you, a quiet, like, on this video, helps more than you would think. And if this happens to be your first night here, staying a little longer, maybe joining the quiet group who keeps coming back for these stories, means you will not miss the night still ahead of us. I would also love to know where you are joining me from tonight, and what time it happens to be where you are right now. Drop it in the comments if the feeling strikes you. I go through every single one, and it still amazes me how many corners of the world end up listening to the exact same story at the exact same moment without ever knowing about each other. Now, if you can, dim the lights a touch more, maybe let a soft fan hum somewhere behind you, and if somewhere along the way tonight your eyes grow heavy and you drift off before we reach the end, that is completely fine. Honestly, that is the whole point of being here. Tonight we're going to sit inside a question that most people never think to ask out loud, the kind of question that sounds almost silly at first, and then quietly refuses to leave you alone once it settles in. We will look at rock that seems to remember things it should not be able to remember. We will look past 150 million years of dinosaurs walking over resources they never once touched. We will ask what a buried city might actually look like after 60 million years underground, and whether the moon sitting quiet and untouched above us every single night might be holding on to a kind of memory Earth itself lost a long time ago. And before the night is through, we will turn that same question toward you, toward the ground beneath the very room you are lying in right now, the same patient, quiet dirt that has already outlived so many things it never bothered to remember. But every story needs a beginning, so let us start with one tired scientist, a desk lamp, and a stubborn question he could not quite put down. It was an ordinary evening in New York City, the kind where the last of the daylight goes soft and orange against glass towers, and most of the building around him had already gone quiet for the night. Gavin Schmidt stayed behind at his desk. He was a climate scientist, the kind who spent his working life inside numbers. Most of us would find bewildering sitting on an upper floor, above a narrow stretch of Broadway, that thousands of tourists walk past every single day without a second glance upward, never guessing what quietly happens on the floors above the sidewalk. Outside his window, the city was doing what it always does after dark taxis sliding past in long amber streaks. The hum of a subway grate somewhere below 100,000 small lights standing in for 100,000 strangers he would never know anything about. None of that reached him, not really. His screen held his whole attention, a graph made of jagged lines and quiet colours, each one tracing a version of Earth's temperature stretching back millions upon millions of years. Schmidt was not thinking about the future that particular night. He was thinking about the deep past. Buried inside old layers of seafloor mud and ancient stone, there are moments scientists call hypothermal sudden jumps in the planet's temperature that happened long, long before anything resembling a human ever stood upright. Schmidt spent his days comparing those ancient spikes against the fingerprint our own civilization is leaving in the atmosphere right now, hunting for patterns, for old warnings buried in stone, for anything. The deep past might still be able to teach the uneasy present. One signature in particular kept pulling his attention back again and again, the way a familiar song sometimes catches in your head for no reason at all. 56 million years ago, something pushed the planet's temperature up by roughly 5 to 8 degrees Celsius, and it happened fast enough geologically speaking that scientists still argue over exactly what triggered it even now. A fire hose of carbon released into the air and ocean thick enough to leave a scar still readable in stone, laid down long before a single flower had ever bloomed the way flowers bloom today. Layer after layer of ancient mud holding on to a memory of heat from a world that had no ice caps left at all. Geologists have a name for the finer detail hidden inside that scar too. A shift in the chemistry of ancient carbon called a carbon isotope excursion. A phrase that sounds cold and clinical until you understand what it actually means. It means that somewhere in that stretch of ancient time an almost unthinkable quantity of carbon poured into the sky and ocean all at once, all together, fast enough that the planet itself struggled to absorb the shock. Schmidt had studied that particular scar more times than he could count. But that evening, staring at the same graph for what felt like the 100th time, a strange thought slid in sideways, uninvited, the kind of thought that arrives quietly and then simply refuses to leave. What if that signature was not entirely natural? Not that he believed it. Not really. Not yet. It sat closer to an itch than to a real conviction. Still, once the thought existed, it would not lie down again. What would it actually look like buried deep in the rock if an industrial kind of civilization had risen and fallen long before we ever showed up? Would it look any different from an ordinary climate accident? Would anyone even notice 60 million years later, buried under that much stone? Or would we simply mistake it for something the planet had done entirely on its own, the way Schmidt himself very nearly had, staring at that same curve for years and years? He knew exactly how the idea would sound if he said it out loud in a meeting. A little embarrassing if he was honest for a scientist with his standing. The sort of notion you might expect from a late-night documentary, not from a serious researcher at one of the country's most respected climate institutes. Some colleagues he suspected would smile politely and change the subject. Others, though, might take it more seriously than he expected, because underneath the strange premise sat a careful, almost mathematical kind of question about the limits of what deep time will actually allow anyone to know for certain. Maybe the graph in front of him held nothing but ordinary Earth chemistry doing exactly what ordinary Earth chemistry does. Maybe it was hiding something else entirely, something nobody had ever thought to search for. Or maybe, and this felt like the most honest answer of the three nobody alive could say for certain, not yet. He decided the question deserved more than a single quiet evening. Roughly 250 miles to the northwest, near the shore of a great lake in upstate New York, a different kind of scientist happened to be circling a related puzzle just from the opposite direction entirely. Adam Frank taught astrophysics at a university in Rochester, near enough to the lake that a cold winter breeze off the water could rattle a window pane most nights of the year. Most of his working life was spent staring outward instead of downward, past the roof of his own building, past the edge of the solar system, entirely toward the possibility of intelligent life on planets we have never visited and likely never will. He had spent years turning over a stubborn old riddle in his field, the sort that keeps astronomers awake long past midnight. If advanced civilizations are common across a galaxy this vast, then where is everyone? Why does the night sky look so empty, so silent, so apparently free of anyone else at all? When Schmidt brought him this new stranger question about Earth's own buried past, something clicked for Frank almost immediately. Before anyone goes searching the stars for some distant advanced civilization, he realized it might be worth asking a smaller, stranger version of that same question much closer to home. Could we even detect an advanced civilization that once made its home right here on our own quiet planet, if it rose and fell tens of millions of years before the very first human ancestor ever opened their eyes? The two men had never actually worked together before that year, and for a while their entire collaboration happened through nothing more than long emails and the occasional evening phone call, one of them in a bright office above Broadway, the other beside a dark, quiet lake 300 miles away. A climate scientist and an astrophysicist trading a question back and forth that belonged to neither of their fields perfectly, and yet somehow belonged to both. The two of them sat with the idea for months, testing it, poking holes in it, trying honestly to talk each other out of it before they let themselves believe it deserved a real paper. They submitted their work in the autumn of 2017, revised it carefully through the following winter, and watched it finally appear in the spring of 2018 inside a modest scientific journal called the International Journal of Astrobiology. The entire argument, once typed out properly, took up barely 9 printed pages tucked quietly among far less unsettling research. Short, carefully reasoned, and considerably heavier than its length would ever suggest to anyone who had not actually opened it and gone through it sentence by sentence. They gave the underlying question a fittingly odd nickname, one borrowed from an old piece of popular fiction that has nothing at all to do with real geology. We will circle back to exactly where that peculiar little name came from later tonight, because the story behind it is almost as good as the puzzle itself. What mattered far more than the name in that first paper was the seriousness sitting quietly underneath it. Schmidt and Frank were never claiming that some lost empire of industrious dinosaurs had actually existed marching around with tools in hand. They were asking something narrower, and in its own way far more uncomfortable to sit with. If something like that had happened once, would any evidence even survive long enough for us to find it today? Or has the planet already erased every trace over and over so thoroughly and so patiently that an entire civilization could rise, thrive, and fall away, leaving nothing behind but a strange little bump on a chart that a tired scientist might glance past without a second thought the way Schmidt almost had? Think about that for a moment, lying there in the dark. 2 grown men, both with real reputations to protect, both trained to distrust exactly this kind of speculation, choosing to put their names on it anyway. Not because they believed the answer was yes, simply because nobody in more than a century of digging through the earth had ever properly asked the question and shown their work. Word of the paper spread slowly at first, then faster than either man expected. A few newspapers understandably went straight for the most amusing angle they could find, and for a short while, somewhere on the internet, a headline or two floated around suggesting dinosaurs might have built their own version of a shopping mall. It is admittedly a funny image to hold on to right before bed. Underneath the jokes, though, something quieter and more serious was happening. Some readers dismissed the idea outright, calling it a clever thought experiment and nothing more fun to imagine over coffee and forget about by lunchtime. Others, including scientists with decades of careful fieldwork behind their names, found themselves oddly unable to dismiss it quite so easily. Because underneath the playful framing sat an uncomfortable true fact about our own planet, one most of us never stop to consider on an ordinary day. The ground beneath your feet does not keep a clean, complete diary of everything that has ever happened on it. It keeps fragments, torn pages, whole chapters gone missing, folded under mountains or dragged down into the deep furnace beneath the crust and slowly melted back into nothing at all. So maybe the rock remembers nothing unusual whatsoever, and this whole question turns out to be nothing more than a beautiful piece of speculation. The kind scientists allow themselves once in a while late at night just to see where it goes. Maybe it remembers something we have simply never learned to interpret correctly, hidden in plain sight this entire time. Or maybe, and this seemed to be the answer both scientists felt most comfortable giving out loud, we will not know which one is true until we understand far more precisely than we do tonight exactly what a civilization would even need to leave behind to still be found again after 60 million patient years of silence. Lying there right now in the dark, in your own bed, on your own patch of ground, it is worth sitting with that thought for just a moment longer. Somewhere beneath you right now there is stone that has been quietly sitting in place for longer than any of us can properly imagine. Stone that has already watched entire mountain ranges rise up and wear back down to nothing. Stone that has already outlasted creatures far stranger than us, and will very likely outlast us too one distant day. It keeps no diary. It plays no favourites. It simply presses everything down layer over patient layer and waits. 2 scientists, one office above a busy street, one small building beside a quiet lake, looked at that same patient stone and asked a question most of us never think to ask. Not because they wanted headlines, not because they wanted to unsettle anyone right before sleep, although admittedly here we are. They asked it because the honest answer to whether something like us ever came before us is still even now simply unknown. And that is exactly where we are headed next, into a stranger question sitting just underneath this one. Before anyone can go looking for the fingerprints of a vanished civilization after all, we first have to agree carefully and honestly on what actually counts as one in the first place. So let's start there. What actually counts as a civilization in a way careful enough that a scientist could put a real number on it? Picture a small cinder block building tucked between wooded ridges in West Virginia, early November of 1961. Nothing fancy about the place. A radio observatory in the middle of nowhere, the kind of spot where the loudest sound most nights was static drifting in from somewhere out past the edge of the galaxy. A young astronomer named Frank Drake had invited a handful of scientists there for a quiet, informal gathering, and before anyone else even arrived, he stood alone at a chalkboard trying to work out how to organize a conversation that did not yet have any real shape to it. Drake himself was no stranger to that observatory. A year earlier, using the very same telescope, he had spent several patient weeks, quietly pointed at 2 nearby sun-like stars, listening at the exact radio frequency hydrogen itself naturally emits, on the theory that any other civilization curious enough to look for neighbours might choose that same familiar frequency to say hello. Nothing came through. Only static and patience and the ordinary hum of the universe minding its own business. That quiet failure, oddly enough, is what convinced the National Academy of Sciences the whole subject deserved a proper conference in the first place. The guest list, it turned out, was small but remarkable. A Nobel-winning chemist named Melvin Calvin flew in, and partway through the 3 days he actually received a phone call at the observatory, letting him know he had just won that very prize which must have made for one strange, wonderful afternoon. A dolphin researcher named John Lilly came too, which is the reason the small group half-jokingly started calling themselves the Order of the Dolphin. And tucked near the bottom of the invitation list, the youngest person in the room, by a wide margin, sat a 27-year-old graduate researcher named Carl Sagan, a name almost nobody outside a small circle of astronomers recognized yet. Before the meeting properly began, Drake wrote out a simple equation on that chalkboard, half, to keep his own thinking straight half, because he suspected a room full of brilliant, strong-willed people needed some kind of shared structure before the conversation could go anywhere useful. Nothing dramatic, just a chain of separate factors multiplied together one after another. How many stars form each year in a galaxy like ours? What share of those stars carry planets around them? How many of those planets could actually support life to begin with? Of the ones that could, how many ever produce life at all? Of those, how many go on to produce something we would call intelligent? And finally, how many of those intelligent species ever build the kind of technology capable of reaching across empty space? And roughly how long that technology tends to last before it falls silent again? That one quiet afternoon produced what astronomers still call the Drake equation, and for more than 60 years now, it has shaped how an entire field thinks about the odds of not being alone out here. Here is a slightly humbling postscript to that story, one worth sitting with for a second before we move on. More than 60 years later, working scientists will tell you quite openly that they have only meaningfully pinned down 2 of those 7 original factors. We now have a fairly confident number for how many stars carry planets, and a decent estimate for how many of those planets sit in a zone friendly enough to support life. The remaining terms, the ones asking how often life actually appears, how often it becomes intelligent, how often intelligence becomes technology, and how long that technology tends to survive once it exists, remain almost exactly as uncertain today as they were on that chalkboard in 1961. It is in its own quiet way an oddly comforting kind of honesty. An entire scientific field 60 years on still willing to say plainly, we simply do not know yet. Here is the part almost nobody stops to notice, though, tucked quietly inside that whole elegant framework. Baked into it, unspoken, but always assumed, sits the idea that each planet only gets one attempt. One roll of the dice. Life either climbs all the way up to a technological civilization once, or it never does, and either way that is treated as the end of the planet's story, full stop. Schmidt and Frank's question, the one we sat with earlier tonight, points a quiet flashlight directly at that hidden assumption. What if a planet is not actually limited to a single attempt at all? What if Earth already spent one of its turns long before any of us arrived to spend ours? And if that turns out to be true, what would it even do to 60 years of careful, well-respected astronomical math, built this whole time on an assumption nobody thought to seriously test? Maybe the old assumption still holds up perfectly fine, and Earth really has produced exactly one technological species across its entire 4.5 billion year history, and that one species happens to be listening to these words right now. Maybe it does not hold up at all, and the true number of attempts a habitable planet gets is far higher than generations of careful scientists quietly assumed while writing that equation across chalkboards and whiteboards for the past 6 decades. Nobody currently working in the field claims to know for certain which answer is the right one. Not with any real confidence. Not yet. So if a planet really can host more than one attempt at civilization, the next question follows almost naturally. What precisely are we counting? What is the actual bar a species has to clear before scientists are willing to use that specific word civilization in its strict technical sense? This is where Schmidt and Frank made a choice that surprised a fair number of readers when their paper finally came out. They did not define civilization by cities or by written language or by anything you could simply point to and photograph. They defined it instead by energy, specifically by whether a species has crossed the threshold of harnessing outside energy sources at a truly planetary scale, not just enough to warm a village or feed a handful of families, but enough to visibly, measurably reshape the chemistry of an entire world. By that particular definition, something curious happens to our own story. Humanity has only been running large-scale industry in the strict sense they mean for something like 300 years, counting roughly from the point mass production truly took hold. 300 years. Complex life has existed on Earth's land surface for something closer to 400 million years. Sit with that gap for a moment if you're still awake enough to enjoy that kind of arithmetic, and you will notice our entire industrial era barely registers as a rounding error against a backdrop that much older, which means, strange as it sounds, being human and being a civilization in the technical sense these two scientists are using are not actually the same thing at all. You could picture an intelligent, curious tool making species living on this exact planet for thousands of generations, hunting, gathering, telling stories around a fire, building boats and tracking stars, never once crossing that particular threshold. And by Schmidt and Frank's own careful definition, they would not count as a civilization yet either. So what actually flips the switch? Is it the first city wall, the first piece of writing scratched into wet clay? Or is it something far less romantic than either of those, something closer to the first moment a species starts pulling stored, ancient energy out of the ground faster than the planet can quietly replace it? It is worth noticing, too, how gradual that particular crossing tends to look from the inside. Nobody wakes up one morning having built a civilization. For most of human history, our own species burned wood, and later a modest amount of coal at a scale small enough that the planet barely noticed the difference. The real threshold, the one Schmidt and Frank are actually pointing at, is not about fire itself. Every early culture on Earth had fire. It is about the moment a species begins pulling energy that took the planet millions of years to store away and burning through it in a handful of generations instead. Consider for a moment an entirely different kind of achievement, one built without a single ounce of industry behind it. Somewhere south of Cairo, a limestone monument has stood in the desert heat for roughly 4,500 years, built stone by enormous stone using nothing but human muscle, rope patience, and an almost unimaginable amount of organized labor. It remains one of the most staggering feats of coordination in the whole of human history, the kind of structure that still leaves modern engineers quietly impressed. And yet by Schmidt and Frank's definition, it does not count as evidence of an industrial civilization either. No outside energy source was ever harnessed to raise it. Nothing pulled from underground. Nothing that reshaped the planet's chemistry in a way a geologist digging through that layer of rock 60 million years from now could ever hope to detect. Just generations of people, muscle and time. That distinction trips a lot of people up the first time they hear it, and it is worth pausing on for a second because it is one of the more common misreadings of this whole idea. We tend to measure the past by how impressive something looks standing in a photograph. Scientists testing this particular hypothesis are asking a colder, quieter question, instead one about energy, not appearance, one about chemistry, not architecture. The same test, it turns out, quietly rules out some remarkable builders from the animal kingdom too, and this is usually where people find the definition most surprising. Termite mounds can rise taller than a grown person and stay cool inside through brutal heat, engineered with a kind of natural air conditioning, built from nothing but mud, saliva, and blind instinct passed down through countless generations. Beaver dams can reroute entire streams, drown whole meadows, and quietly reshape a valley's water table over the course of a few patient seasons, sometimes visible from an airplane window if you know where to look. Both are remarkable, honestly worth admiring. Neither one by this definition comes anywhere near counting, because both are built entirely from muscle power, and whatever material happens to already be lying around locally. Neither one ever reaches down into the ground for ancient concentrated stored energy, the way an industrial society eventually does. That single difference, small as it sounds out loud, turns out to matter more than almost anything else in this whole conversation. Here is a question worth sitting with for a moment, and I mean that honestly, not as some rhetorical trick to fill airtime. If you had to guess right now, lying there in the quiet, what do you think the real dividing line actually is between an impressive structure and an honest-to-goodness civilization? Is it intention, awareness, or is it simply a matter of scale? One colony of termites against one entire species, learning to burn the fossilized memory of our ancient forests just to stay warm through a single winter. Scientists studying this question do not fully agree with each other either, which is in its own strange way a comforting thing to hear on a night like tonight. Maybe the honest dividing line really is exactly what Schmidt and Frank propose: energy pulled from outside the immediate environment at a scale large enough to leave a mark on an entire planet's chemistry. Maybe there is some other threshold, entirely something nobody has properly identified, yet sitting quietly between muscle power and industry, waiting patiently for the right person to finally notice it. Either way, tonight's honest answer sits in the very same uncertain place as the last one. Nobody has proven it one direction or the other. And there is a second smaller assumption worth naming here too, one that rarely gets much attention outside academic circles. Both the Drake equation and the Silurian hypothesis quietly assume that a civilization, once it appears, either keeps climbing forever or ends abruptly. Real history. The small slice of it we actually have on record rarely works that cleanly. Empires stall. Technology stagnates for centuries, then leaps forward again without warning. If an older civilization ever did rise on this planet, there is no particular reason to assume its story moved in a straight line, either, which makes the whole search even messier than a simple yes or no question would suggest. There is something quietly strange about applying all of this to yourself lying there right now. This exact version of you tonight belonged to the very first generation of your species ever to count as a civilization by this strict energy-based definition. Your great-great-grandparents likely did not. Somewhere out past a few more generations back, an entire unbroken line of ancestors, every bit as clever, as capable, as fully human, as you are, simply never crossed that particular threshold through no fault of their own. The switch had not been flipped yet. You happen to have been born on the side of history where it already had been. It is a strange kind of inheritance when you think about it, this business of counting as a civilization at all. Nobody chooses the century they arrive in. A person born in a small farming village 300 years ago could have been every bit as sharp, as curious, as capable of wonder as anyone listening to this story tonight, and by Schmidt and Frank's own definition, their world simply had not crossed the line yet. You did nothing to earn your place on this side of that threshold. It was simply handed to you along with electricity and steel and everything else, quietly running in the background of the room you're lying in right now. What we do know is this much. If a threshold like that truly exists, and if it really can be crossed more than once across the long life of a single planet, then the next honest question stops being whether it happened before us at all. The next honest question is simpler than that and colder, and a little harder to shake once you actually hear it spoken out loud. If it did happen before, would anything even survive long enough physically, chemically buried deep underground for anyone to still find it today? In the spring of 1869, a one-armed veteran of the Civil War named John Wesley Powell pushed 4 wooden boats out into the swollen current of the Green River, heading toward a stretch of canyon that no expedition had ever mapped from the water before. He had lost his right arm at a battle called Shiloh, and yet there he was 6 years later preparing to run the Colorado River through country so remote that some of the men on his own crew half believed they might drop off the edge of a waterfall. Nobody had ever charted and simply never be heard from again. The boats themselves were nothing special. Heavy oak rowboats built for calmer rivers loaded down with barely 3 months of food and instruments that had no business surviving a single hard rapid, let alone the dozens waiting somewhere downstream. Local trappers who heard about the plan reportedly tried to talk Powell out of it entirely, warning him about a canyon so deep and so violent that sunlight barely reached the water at the bottom. He went anyway. Some of his men would not make it to the end of the trip at all, choosing instead to climb out of the canyon on foot, rather than face one more set of rapids, a decision that, as it turned out, they did not survive somewhere out on the surrounding plateau. They did not fall off any waterfall. What Powell found instead staring up at the canyon walls from the bottom of that gorge day after day was stranger, and in its own quiet way far more unsettling than any rapid. Low down in the canyon, dark twisted rock stood on end, tilted and folded like a rug someone had shoved into a heap. After a long winter, the kind of rock that had clearly been through violence long before any human eye ever saw it. Directly above it, without any gradual transition at all, sat neat, flat, horizontal layers, stacked calmly like pages in a book that had never once been disturbed. Powell noted the odd boundary in his journal, and moved on, understandably distracted by the more immediate business of staying alive on an unmapped river. It would take more than a century of careful dating for anyone to understand exactly what he had actually stumbled onto. The rock below that strange line turned out to be roughly 1.7 billion years old. The rock resting directly on top of it with nothing in between was only about 500 million years old. Somewhere in that gap, more than 1 billion years of Earth's history simply is not there, not hidden, not buried somewhere else waiting to be found. Gone the way a chapter goes missing when someone rips the pages clean out of a book and no copy exists anywhere else on the planet. Geologists eventually gave that vanished stretch of time a fittingly dramatic name, the Great Unconformity, and it does not only show up in that one canyon. Versions of the same suspicious gap have turned up on nearly every continent on Earth, almost always swallowing that same general stretch of deep time, as though something happened to the whole planet at once, and quietly erased the record of it everywhere simultaneously. Sit with that for a moment. One of the most carefully studied, most photographed, most beloved rock formations on the entire continent, and even it is missing more time than it actually preserves. If a billion years can slip out of one of the best exposed, most intensely studied cliffsides in North America, what does that tell us about all the ordinary, unremarkable, unphotographed patches of ground everywhere else on the planet? What else has quietly gone missing that nobody has ever noticed was even absent in the first place, simply because there was no neat line left behind to mark the gap? Some geologists think the Grand Canyon's version of this gap was carved out by an ancient bout of ice, an era scientists sometimes call Snowball Earth, when glaciers may have scraped entire mountain ranges down to bare stone. Others point instead toward the slow, violent breakup of an ancient supercontinent, its pieces dragging and grinding across each other for tens of millions of years, tearing away whatever rock happened to be sitting on top at the time. Both explanations remain seriously debated among people who have spent entire careers on this single question. Neither one is fully settled. Here is a question worth turning over for yourself honestly before we move past it. If someone told you an entire billion years had quietly vanished from the most studied rock formation on the continent, would your first instinct be curiosity, or would it be a kind of quiet unease? The sense that the ground itself cannot entirely be trusted to tell you the truth. Maybe the gap really was a strange one-time event tied to a specific stretch of catastrophic weather or tectonics that only happened once in Earth's whole 4.5 billion year history. Maybe events like it happen quietly over and over all across deep time, and the Grand Canyon simply happens to be the place we noticed clearly enough to give it a name. As with almost everything we've touched on tonight, nobody can say for certain which explanation is correct. If you are still with me at this hour, take a slow breath before we keep going. Wherever you happen to be resting your head tonight, whatever the clock beside you happens to say, you are welcome to let your eyes settle all the way shut right here if they need to. This particular story has plenty of time left in it, and none of it requires you to stay awake for the ending. Here is where the story gets even less comforting. If you are the kind of person hoping the ground beneath you keeps a tidy diary, roughly 70% of this planet's surface is not rock you could ever walk across at all. It is ocean floor sitting quietly beneath miles of dark water, and ocean floor does not behave anything like the patient ancient stone under a mountain range. New ocean crust is born constantly along cracks running down the middle of every major ocean, glowing orange and black where fresh rock meets seawater. Then slowly, steadily it gets dragged sideways across the seafloor over millions of years like a conveyor belt. Nobody remembers switching on. Eventually it reaches the edge of a continent, gets shoved downward into a trench, and sinks back into the scalding rock of the mantle, melted down completely and recycled into something new. Whatever happened to sit on top of that patch of ocean floor, whatever quietly settled onto it and waited, goes down into the furnace along with everything else. Almost none of the ocean floor covering this planet right now is older than about 200 million years. There's exactly one confirmed exception. A stubborn scrap of ancient seafloor hiding under thick sediment in the eastern Mediterranean dated to somewhere around 340 million years old. And even that single surviving fragment is considered an unusual fluke, a lucky corner of crust that somehow slipped past the conveyor belt instead of being swallowed on schedule like everything around it. Meanwhile, on land, a handful of continental rocks in places like Western Australia and northern Canada have survived more than 4 billion years, roughly the age of the planet itself. The gap between those two numbers, 200 million against 4 billion, tells you almost everything you need to know about how unevenly this planet keeps its own records. Think about what that actually means for a moment. For most of this planet's surface, deep time does not fade slowly the way an old photograph yellows at the edges over the decades. It gets wiped completely clean on a rolling schedule roughly every couple 100 million years, and then quietly rebuilt from scratch with absolutely no memory of whatever used to be sitting on top of it. So here is a truly uncomfortable question worth turning over in your mind for a second, lying there in the dark. If a scar like the one we talked about earlier tonight, that sudden burst of ancient warming 56 million years back, had happened to leave its evidence resting on ordinary seafloor instead of dry land, would that evidence even still exist anywhere on the planet today? Or would it have already finished one full trip through the recycling bin, melted down completely, and rebuilt as something with absolutely no memory of what it used to be? Maybe whatever we are quietly searching for happened to leave its mark on old stable continental rock, the patient kind that can survive for billions of years relatively undisturbed. That would be in its own strange way the lucky outcome. Or maybe it happened somewhere the ocean floor has already devoured and rebuilt itself twice over, since in which case the evidence is not lost, not hidden, not waiting patiently to be dug up by the right determined scientist with the right expensive equipment. It is simply permanently unrecoverable, not misplaced, erased. There is honestly no way for anyone alive today to know which of those two situations we are actually living inside. And even setting aside whether the ground itself survives, there is one more brutal filter standing between any living creature and the far distant future one that has nothing at all to do with tectonics. Paleontologists have a blunt, half-joking shorthand they sometimes use with each other, a kind of dark professional humour about their own field. They will tell you only half seriously that the rough odds of any individual creature actually becoming a fossil sits somewhere around 1 in a million. Nobody treats that figure as a precise measurement, exactly more a way of expressing just how staggeringly unlikely the whole process really is. Something has to die in exactly the right place near a river or a swamp or a shallow sea somewhere. Sediment is actively piling up rather than washing away. It has to be buried quickly before scavengers or simple weather get to it first, before the ordinary business of decay reduces it to nothing more than a faint stain in the soil. The right minerals need to seep in at exactly the right pace, under exactly the right chemical conditions, slowly replacing bone with stone atom by atom. And then that fragile little pocket of rock has to survive everything we just spent the last several minutes describing untouched for millions upon millions of years, before anyone digs or drills or blasts in precisely the right spot to notice it was ever there at all. It is worth pausing here for a comparison, because our species exists inside a very different relationship with memory than the planet does. Human beings have spent the last several thousand years actively fighting against this exact kind of erasure on purpose. We carve words into stone specifically because stone lasts. We build libraries and archives and now server farms humming away in the dark, all in an effort to make sure information survives us. The planet does nothing of the sort. It has no interest in preserving anything. Rock gets folded, melted, and rebuilt with the same blank indifference, whether it once held the bones of a curious civilization or nothing more than mud. Our entire modern instinct toward preservation, oddly enough, is a rebellion against exactly the kind of quiet, patient erasure we have spent this whole segment describing. Picture for a moment everything alive on this planet tonight. Every bird resting in a tree, every fish drifting somewhere in the dark ocean, every insect tucked into the bark of a tree outside your window. The overwhelming majority of them, when they die, will leave behind nothing. No bone, no shell, no trace of any kind that will still exist in even 10,000 years, let alone 10 million. That has always been true for every creature that has ever lived, human or otherwise. The fossil record we do have is not a complete family album of life on Earth. It is a handful of surviving snapshots saved almost entirely by accident out of a library that has mostly already burned down without anyone bothering to notice the fire, which means when you really add it all together tonight, the odds facing any hypothetical vanished civilization stack up in a brutal, almost unfair way. First, its physical remains would have needed to survive the ordinary savage odds against fossilization in the first place, the same odds working against every creature that has ever lived. Then, whatever did somehow survive that filter would have needed to be resting on ground stable enough to make it through hundreds of millions, maybe billions of years of tectonic recycling without ever once being folded, buried, melted, or quietly swallowed. And finally, assuming both of those genuine miracles somehow lined up, layered one on top of the other, against every reasonable expectation, someone alive today would still need to happen to dig or drill or blast in exactly the right spot to notice it. Ask yourself honestly, how many places on this entire planet have actually been dug into with that kind of careful, deliberate attention? A tiny fraction of the land surface, and an almost laughably small fraction of the ocean floor. We have by some estimates explored and mapped a smaller share of our own seafloor than we have of the surface of the moon. Most of this planet, even now in an age of satellites and ground-penetrating radar, remains a place nobody has ever properly looked, a kind of enormous patient blind spot sitting directly beneath our feet and under most of the water on Earth. Framed like that, the real surprise is not that we have never found solid proof of an older civilization. The real surprise, honestly, might be that anyone ever expected we would this soon, this easily, with this little of the planet actually examined, which raises a rather strange question of its own, one that has nothing to do with rock or fossils or missing chapters of deep time at all. If this whole idea is careful enough, humble enough, cautious enough to be published in a serious scientific journal by two respected researchers, why on earth does it carry a name that sounds like it wandered in straight out of an old science fiction television show? Here is the answer, and it is so much sillier than you are probably expecting. Picture a Saturday evening in Britain, the last day of January in 1970. Rain on the windows in most of the country, the kind of damp winter dark that settles in early and stays. Families arranged around a television set in the corner of the sitting room, many of them watching a programme that had only weeks earlier done something remarkable for the first time in its history. It had started broadcasting in colour. The show was Doctor Who, and that particular winter it was in the middle of reinventing itself completely. A new actor named John Pertwee had just taken over the title role, all velvet jackets and theatrical charm. The stories had been pulled back down from the far corners of the galaxy and planted firmly on Earth in quarries and research facilities and English villages, which had rather a lot to do with the fact that filming in colour cost considerably more money than filming in black and white. And on that evening the second story of the new season began. 7 episodes stretching across the next several weeks. It was called Doctor Who and the Silurians, written by a man named Malcolm Hulke. The premise went like this. Deep beneath the moors of Derbyshire, in a network of caves sitting directly underneath an experimental nuclear research centre, something ancient wakes up. Not aliens, not monsters from another world. An intelligent civilization of reptilian beings who had built a sophisticated society on Earth long, long before human beings existed, and who had gone into a kind of deep hibernation underground when they believed a catastrophe was coming for their world. They had slept through the entire rise of humanity, and now the vibrations from the research facility had quietly woken them up into a planet that had been thoroughly and permanently taken over by someone else while they were asleep. What makes the story worth remembering beyond the costumes is that Malcolm Hulke refused to write the awakened species as villains. They are not invaders. They have by any reasonable measure a legitimate prior claim to the ground everyone is standing on. The Doctor spends most of the serial trying to broker a peace between two civilizations who each believe the planet belongs to them, and the ending is remarkably bleak by the standards of a family television program. Human military authority resolves the situation by sealing the caves with explosives over the doctor's furious objection, and the final moments are not triumphant at all. They are the sound of somebody realizing his own side chose extermination over negotiation. That is the name. That is where it comes from. Two respected working scientists publish in a peer-reviewed paper about the limits of the geological record named The Whole Framework, after a British science fiction serial from 1970 about sleeping lizard people under a hillside in Derbyshire. They were entirely open about it too. Tucked into their paper is a short, unembarrassed footnote explaining exactly where the name came from, along with a quiet acknowledgement that it is not, strictly speaking, a very good name at all. Because here is the part that makes actual geologists wince a little. There really is a Silurian period in Earth's history. It is a real formally recognized chunk of deep time running from roughly 443 million years ago to about 419 million years ago. And during that stretch, the land surface of this planet was almost aggressively boring. Small, low plants beginning to creep out of the water. Some early arthropods, the ancestors of insects and spiders, poking around in damp places. Nothing you could reasonably call a reptile. Nothing with a backbone walking around on dry land at all, in fact. The idea of an advanced reptilian civilization building anything during the actual Silurian period is, scientifically speaking, roughly as plausible as an advanced civilization of pond scum. The show's writers seem to have realized this fairly quickly. In a later story featuring related creatures, the Doctor pointedly refers to them as Eocenes, instead an attempt at a correction, which is unfortunately also wrong because the Eocene sits on the opposite end of the timeline entirely long after the age of dinosaurs ended. Fans of the show eventually gave up and settled on their own unofficial name for the species, which is probably the most sensible outcome anybody involved could have hoped for. So we have a serious scientific hypothesis published by a climate researcher and an astrophysicist named after a fictional species whose own name was scientifically incorrect from the very first episode, and whose attempted correction was somehow even more incorrect than the original mistake. Sit with the strangeness of that for a second. There is something almost endearing about it, honestly. It is the kind of detail that reminds you science is not conducted by faceless institutions, but by actual people. People who watch television as children, who let their own influences leak into their work, and who occasionally make choices that a serious committee would never have approved. I would go a step further, actually. I think the choice tells you something real about both men. You do not attach a name like that to your own work unless you are comfortable being laughed at a little. There is a kind of confidence in it, the confidence of researchers who know the argument underneath is solid enough to survive the packaging. Now, if you want to know where that word Silurian originally came from before any of this, the story gets older and considerably more human. Travel back to 1835 to a Scottish gentleman geologist named Roderick Murchison. He was by most accounts an ambitious and rather grand personality, a former soldier turned scientist, who had a habit of naming things and expecting the names to stick. Working through layers of ancient rock in the border country of Wales, he decided to name a whole period of geological time after the Silures, an ancient tribe from that region who put up a long, stubborn resistance against Roman conquest. Take a moment with that chain of naming because it borders on the absurd when you lay it out end to end. A tribe of Welsh warriors who fought the Roman army. Their name given 18 centuries later to a slice of deep time containing nothing but early plants and small crawling creatures. That slice of time then borrowed in 1970 by a television writer for a fictional race of reptile people who could not possibly have existed during it. And that fictional race in turn borrowed again in 2018 by two scientists trying to ask a careful question about whether Earth might have hosted a civilization before ours. Four completely unrelated ideas stacked on top of each other across nearly 2,000 years, all resting on the name of a group of people who never wrote a word about geology and had absolutely no idea any of this was coming. There is another layer to the Murchison story, and this one is less funny. At almost exactly the same time, another geologist, a clergyman and Cambridge professor named Adam Sedgwick, was working on rocks in a different corner of Wales. The two men were friends. They'd gone on field expeditions together, shared notes, and helped each other's careers. Sedgwick named his own stretch of ancient rock the Cambrian after the old Roman name for Wales, and then the two systems collided. It turned out that the rocks Murchison called Silurian and the rocks Sedgwick called Cambrian overlapped in the middle. Each man believed his own naming had priority. Each expanded his claim over the disputed layers. What began as a technical disagreement between two colleagues curdled over the following years into one of the most bitter public feuds in the history of British science. They argued in print. They argued at meetings. The friendship did not survive it, and both of them went to their graves without reconciling, still each convinced the other had stolen ground that rightfully belonged to him. The disagreement was finally settled in 1879 by a geologist named Charles Lapworth, who proposed a straightforward compromise. The disputed rocks in the middle, he suggested, should simply be given their own name and their own period. He called it the Ordovician, after yet another ancient Welsh tribe, and the field accepted it. Murchison had been dead for 8 years by then. Sedgwick had been dead for 6. Two men spent a substantial portion of their working years fighting over where one invisible line in the rock should sit, and the solution that ended the argument turned out to be so simple that a third party could propose it in a single paper once neither of them was around to object anymore. I find that story quietly humbling, and I suspect you might too. Both men were serious, capable scientists who contributed a great deal to a field that barely existed yet. Neither of them was a fool, and yet the thing that consumed years of their attention was in the end a question about labels rather than about the rocks themselves. The rocks were exactly the same rocks the whole time. They did not care what anybody called them, and they have not moved since. Take a breath here if you need one. Let your jaw unclench. Let your shoulders sink a little further into whatever you're resting on. There is no rush at all through the rest of this. Now you might reasonably be thinking that all of this is just charming trivia, a funny origin story for a strange name and nothing more. I would push back on that gently because the name a scientific idea carries turns out to matter far more than most people assume. Consider what happened to another idea entirely. In the middle of the 20th century, a British astronomer named Fred Hoyle was defending a theory that the universe had always existed in more or less its present state, expanding gently and continuously forever, with no beginning at all. He was arguing against a rival theory, one suggesting the entire universe had erupted from a single unimaginably dense point at some specific moment in the past. During a radio broadcast, Hoyle described the rival idea using a short, punchy phrase, Big Bang. Whether he intended it as mockery is still debated. Hoyle himself insisted later in life that he had simply been reaching for a vivid image that ordinary listeners would understand. Either way, the phrase escaped into the world and refused to be recaptured. The theory Hoyle spent decades opposing is now the mainstream scientific model for the origin of the universe, and it carries permanently a nickname coined by its most famous critic. There is a kind of poetic justice in that which I have always enjoyed. There is a less amusing version of this problem too. In the early 1990s, a group of researchers identified a gene that plays a central role in how the bodies of developing embryos organize themselves. Following a tradition in their field of giving genes playful names, they named it after a video game character that was popular at the time. It was funny in the laboratory. It became much less funny later when that same gene turned out to be involved in serious developmental conditions in human beings, which meant that clinicians were eventually put in the position of sitting across from a worried family and explaining a devastating diagnosis using the name of a cartoon hedgehog. Several doctors have argued publicly, and I think reasonably, that the joke stopped being a joke the moment it entered a hospital room. So here is a question I would like to put to you, and I'm curious what your instinct says. Do you think a scientific idea should be allowed to carry a playful name? Does the humour make the science more approachable? More human, easier for ordinary people to care about? Or does it hand critics an easy excuse to wave the whole thing away without ever engaging with what it actually says? There is no clean answer, and the people who work in these fields argue about it among themselves. But I suspect where you land depends a great deal on whether you have ever been on the receiving end of one of those names. For what it is worth, I think the two scientists we have been following knew exactly what they were doing and made the trade deliberately. A paper titled with dry technical language about detectability limits in the sedimentary record would have reached perhaps a few dozen specialists being cited politely and quietly forgotten. Instead, they gave their idea a name with a hook in it, a name that made people stop and ask a question. The paper travelled far outside its field. Ordinary people who had never once opened a scientific journal found themselves thinking seriously about how much of the deep past has actually been erased. The name did that. The cost is that a certain number of people heard it and immediately filed the whole thing under late-night nonsense without ever noticing that the underlying argument is careful, cautious, and considerably more humble than its packaging suggests. That is the trade. Reach in exchange for a permanent shadow of unseriousness. And it is worth stating plainly one more time what the argument underneath the silly name actually is and is not. Neither of those two men has ever claimed a lost civilization existed on this planet. Not once. Their paper is not a search for lizard people, and if you went looking for that, you would come away disappointed. What they argue is narrower, and I think far more interesting. They argue that our methods of examining the deep past have limits we have not properly measured, and that we should figure out precisely what those limits are before we assume the absence of evidence tells us anything reliable at all. Which brings us to the obvious next problem. If you wanted to actually test an idea like this, you could not simply hope to stumble across a buried city. You would need something else entirely. You would need a real event somewhere in the deep past that already looks unsettlingly similar to the mark a civilization would leave behind, so you could study it closely and work out how to tell the difference. And as it happens, there is one. It sits 56 million years back in the rock. It left a scar visible on nearly every continent, and geologists have been arguing about what actually caused it for the better part of a century. And here is the thing about that event. Nobody went looking for it. It was found by accident in the coldest water on Earth by a crew who had gone down there hunting for something else entirely. January of 1987. A drilling ship called the Joids Resolution was working the Weddell Sea off the coast of Antarctica, in one of the least forgiving stretches of ocean anywhere on the planet. If you have never seen a picture of that vessel, imagine a working oil rig that somebody bolted onto the deck of a cargo ship with a derrick standing more than 60 meters above the waterline, tall enough to be visible long before the hull itself comes over the horizon. The target was a spot on the seafloor called Maud Rise, an underwater plateau sitting roughly 3,000 meters below the surface. The crew spent about 2 days on that particular hole, drilling down more than 200 meters into the mud beneath the seabed and pulling up cylinders of sediment about the width of a soda can, section after section, each one representing a slice of time older than the last. Cores like that are not glamorous to look at. They come up as long tubes of grey and brown and beige, and to an untrained eye they look like precisely nothing mud that somebody went to a great deal of expense and discomfort to collect. Scientists on those ships describe splitting them open lengthwise, laying them out under the lights and finding themselves staring at a stripe of colour that should not be there. It helps to understand what a core like that actually is. Think of it as a stack of pages laid down in order oldest at the bottom. Each centimetre is a span of years. Each metre can be tens of thousands of them. And unlike almost every other historical document our species has ever worked with, nobody wrote it, nobody edited it, and nobody had any reason to lie in it. The sediment simply fell year after year and stayed where it landed. At Maud Rise, somewhere in that stack of sediment, the pale carbonate ooze gives way to a band of clay. The chalky, shell-rich material that had been accumulating steadily for millions of years simply stops. Something else takes over. And then some distance up the core, the pale material returns and everything goes back to normal as though nothing had ever happened. That clay band is where the story is. Two researchers, James Kennett and Lowell Stott, spent the following years working through the chemistry locked inside it, and in 1991 they published their findings in a scientific journal. What they had found sitting quietly in a tube of Antarctic mud was one of the most abrupt climate events in the entire history of complex life on this planet. Now, to understand what they actually measured, you need to know about an organism most people have never once thought about, despite the fact that it has been quietly shaping the story of Earth's climate for hundreds of millions of years. They are called foraminifera, and they are single-celled creatures that build themselves tiny shells, most of them smaller than a grain of sand. Some drift near the surface of the ocean. Others crawl along the seafloor in complete darkness, thousands of meters down. When they die, their shells settle layer upon layer upon layer, across the ocean bottom, building up over millions of years into vast blankets of chalky sediment. Here is why that matters. The chemistry each shell locks into itself depends on the water it was built in, the temperature, the chemistry of the carbon available at the time, which means every one of those microscopic shells is effectively a tiny sealed envelope containing a weather report from the exact moment it was made. Stack enough of them in the right order and you have something no historian ever gets to work with. A continuous record written by nobody with no agenda, no exaggeration, and no reason to flatter anyone. What that record showed at Mordrise was a sudden violent shift. Roughly 56 million years ago, at the boundary between two geological epochs, the deep ocean warmed sharply. The carbon chemistry of the entire ocean lurched in one direction all at once, and at exactly the same moment the foraminifera crawling along the seafloor suffered the largest die-off their group had experienced in something like 90 million years. Whole species that had been quietly going about their business for tens of millions of years simply stop appearing in the record above that line. Geologists eventually gave the whole event a rather clinical name, the Paleocene-Eocene thermal maximum, which does not exactly roll off the tongue at bedtime, so let us simply call it what it was, the warming. Let me lay out the numbers because they are the reason this story sits at the centre of everything we have been talking about tonight. Global temperatures climbed somewhere between 5 and 8 degrees Celsius. There was at the peak of it no permanent ice anywhere on the planet. Crocodiles and palm trees existed in the high Arctic. The whole event from the beginning of the disruption to the point where the climate finally settled back down lasted somewhere around 170,000 years. Try to picture the Arctic like that for a second, since it is honestly hard to hold in your head. No ice, no white, swampy forest running right up to the top of the world, with turtles and crocodile relatives moving through the shallows, and a sun that never quite sets for months at a time. That was a real place, and it existed on the same planet you are lying on right now. But the beginning of it, the actual injection of carbon that set the whole thing in motion, may have taken only a few thousand years, possibly fewer. That timing remains one of the most fiercely argued questions in the field, and depending on which laboratory you ask, you will get answers ranging from a handful of millennia down to something uncomfortably brief. And now the number that stops people. Estimates for the total amount of carbon dumped into the atmosphere and ocean during that event range from roughly 2,000 to well over 10,000 petagrams. If that unit means nothing to you, that is completely reasonable, so here is the translation that matters. That range sits squarely on top of current estimates for the total remaining fossil fuel reserves of this entire planet. Sit with that for a moment. 56 million years ago, something on this world took an amount of carbon comparable to every drop of oil, every seam of coal, and every pocket of gas we have not yet burned, and released it into the sky over a geological instant. Nobody knows what. That is not me being dramatic for effect. That is the honest state of the science. There are several serious candidates, and researchers have been arguing about them for more than 30 years. Some point toward enormous volcanic activity in the North Atlantic, where a continent was in the process of splitting apart, magma cooking through carbon-rich sediments, and driving gas up into the air. Others suspect frozen methane deposits on the seafloor destabilizing and belching upward. Some suggest thawing permafrost triggered by a coincidence in Earth's orbital wobbles. A few have even floated the possibility of an impact from space. Each explanation has evidence behind it. None of them has managed to settle the argument. What I find striking is not the disagreement itself, but how long it has persisted. This is not some obscure corner of the field that nobody bothers with. The warming is one of the most intensely studied events in the entire geological record precisely because it is the best natural comparison anyone has for what our own species is currently doing to the atmosphere. Hundreds of researchers, decades of drilling, instruments that can measure the chemistry of a single microscopic shell, and the fundamental question of what pulled the trigger remains open. So here is the question I would put to you lying there in the quiet. If our best minds working with the best instruments we have ever built still cannot agree on what caused a carbon release the size of every fossil fuel reserve on Earth, how confident should we be that we would recognize an unnatural cause if we ever stumbled across one? That is not a rhetorical flourish. That is more or less exactly the question two scientists sat down and wrote a paper about. Take a breath here. Let yourself sink a little deeper into the mattress if you can. Nothing in this story is going anywhere, and there is no part of it you need to hold on to. What happened above the water on land while all this was going on is its own remarkable chapter. The warming rearranged the animal world in a way you can still feel the consequences of today. Mammals had existed for a long time by then, but they had mostly been small, unremarkable creatures scurrying around in the undergrowth. At that boundary in the rock record, three enormously important groups appear on the scene almost simultaneously. The ancestors of horses and rhinoceroses, the ancestors of deer cattle and whales, and the earliest primates, which is to say the branch that eventually produced you. There is a wonderful detail buried in that story too. As the world heated up, some mammal lineages appear to have shrunk. The earliest horses, already small enough to carry around under one arm, got measurably smaller across the warm interval, and grew back afterward. Bodies adapting in real time to a planet that had abruptly changed its terms. I have always found that particular detail oddly moving. Not because it is dramatic, but because it is so ordinary. No extinction, no catastrophe, no last stand. Simply generation after generation of small animals being born slightly smaller than their parents, for reasons none of them could possibly have understood, until the world cooled off and the trend quietly reversed. That is what a planetary emergency looks like from the inside. If you happen to be living through it at the scale of a single lifetime, it looks like almost nothing at all. The ocean, meanwhile, was having a considerably worse experience. All the carbon absorbed into seawater turned it more acidic. In the deep sea, the level at which shells could survive without dissolving rose dramatically in some regions by as much as 2 kilometers. Picture that for a second. An enormous band of seafloor that had been steadily collecting white chalky shell material for ages, and then within a geological blink, everything settling into it starts dissolving on arrival. That is precisely why the pale ooze in that Antarctic core gives way to a stripe of clay. The shells did not stop falling. They stopped surviving the trip down. So here is where it all connects back to the question we started this night with. If you handed that carbon signature to a geologist 60 million years from now with no other context, could they tell you whether it was caused by volcanoes, by melting seafloor ice, by an orbital coincidence, or by somebody burning something? The honest answer, and this is the uncomfortable core of the entire hypothesis, is that the fingerprint left in the rock by a large natural carbon release and the fingerprint left by an industrial civilization burning fossil carbon look far more similar than most people would like. Which is not to say the two are identical. There is one difference, and it is the sharpest tool anybody has found for telling them apart. Right when researchers compare how quickly carbon entered the system during that ancient warming against how quickly our own species is doing it right now, the modern number comes out substantially higher, not by a small margin, by something on the order of 10 times faster. The ancient event terrifying as it was unfolded across thousands of years. Ours is unfolding across a couple of centuries. I find that comparison strangely clarifying rather than frightening, and I want to be careful about how I put this. It tells us that a rapid, unnatural carbon release does leave a distinctive mark, at least in principle. Not a picture of a city, not an artifact. Simply a signature that moves faster than geology usually allows. Which means that if you were hunting for the ghost of a vanished industrial civilization in ancient rock, you would not be looking for ruins at all. You would be looking for something that happened too quickly. And that, I think, is the quietly beautiful part of this whole idea. The evidence would not be a monument, it would be a tempo. There is one more thing worth saying before we move on, and it has less to do with science than with perspective. Everything we just talked about, the heat, the dissolving shells, the shrinking horses, the largest die-off of seafloor organisms in 90 million years, all of it fits inside a stripe of clay a few centimeters thick, sitting inside a mud tube pulled up from beneath a freezing sea. 2 people spent years working out what that stripe meant, and the entire catastrophe, the whole 170,000-year upheaval of an entire planet, is now something you could hold in your hands. That is what deep time does to everything. It compresses, it flattens. Whatever we are all so worried about this week will one day be a few grains of something in a layer nobody bothers to name. I do not say that to make you feel small, by the way. I've never found that idea depressing, and I hope you do not either. There is something restful in it if you turn it the right way around. The planet has absorbed shocks far larger than anything happening right now, and it kept going. Species arrived, adjusted, shrank, grew, and carried on. The stripe of clay in that Antarctic core is not a tombstone. It is closer to a scar, and scars are what a body has instead of a wound. Which brings us finally to the practical question underneath all of this. If the temperature spike alone is not enough to prove anything, and if the rate is only one clue, what else would a vanished civilization actually leave behind in the rock? What are the specific things a geologist should be searching for? Because it turns out there is a list, and some of the items on it are already forming right now, underneath the ground you are lying on. Here is what I find remarkable about that question. We already know the answer works because we have already done it once. Not with a lost civilization, with a very famous one. Come with me to a laboratory in Reno, Nevada, which is not where you would expect this story to happen. It is a dry, high-altitude city roughly as far from the polar ice as an American city can reasonably get. And yet inside one of the research buildings there in a room kept permanently below freezing, scientists spend their working days handling cylinders of Greenland ice. The ice arrives in sections, each one drilled out of a sheet more than a mile thick. It has to be handled with a care that borders on reverence, because every centimetre of it is a year that will never exist again once it melts. Snow falls in Greenland, gets buried by the following winter's snow, compresses under the weight of everything above it, and eventually becomes ice so dense and so old that air bubbles trapped inside it are samples of the actual atmosphere from the year they were sealed. The team in Reno built a machine that melts these cores continuously from one end to the other, feeding the meltwater straight into instruments sensitive enough to detect a few atoms of a given element in an enormous volume of water. Instead of taking a sample every so often, they get a smooth, unbroken chemical stream. A year-by-year chemical diary of the Northern Hemisphere's atmosphere. And in 2018, a research group published what they had found in a stretch of that diary, covering roughly the last 11 centuries before the Common Era through the first 8 centuries after it. They were tracking a soft grey metal, the heavy toxic one that later generations would eventually ban from house paint and drinking water pipes. Now, that metal had no business being in Greenland at all. It does not blow off glaciers. It comes out of the ground, and in the ancient world it came out of the ground for one reason above all others: silver. Roman silver came largely from mines in what is now southern Spain, an ancient rust-coloured river valley, where the water still runs a startling shade of orange from all the minerals it carries. To get silver out of that ore, you had to smelt it, and smelting released enormous quantities of that grey metal into the air as vapour and dust. The prevailing weather carried it north and east across Europe. Some of it drifted all the way to Greenland, and every winter snow fell on top of it and locked it in place. So here is what those scientists in Nevada were looking at layer by layer, year by year. They could see the metal levels climbing as Rome expanded. They could see them dropping sharply during periods of civil war when mining slowed and the economy contracted. They could see the great peak during the long, prosperous stretch we now call the Roman peace, when the empire was at its most productive and the mines in Spain were running at full capacity. And then in the 2nd century of the Common Era, they could see the numbers fall off a cliff. That drop lines up with a devastating epidemic that swept through the empire, arriving with returning soldiers and spreading along trade routes. Historians have argued for generations about how badly that outbreak damaged the Roman economy. Working from written accounts, tax records and archaeology, all of which are fragmentary and all of which are open to interpretation, the ice does not interpret anything. The ice simply shows a collapse in industrial output written in atmospheric chemistry thousands of miles from where any of it happened. Take a second with that, because it is a stunning thing. A civilization that fell apart more than a millennium and a half ago left a measurable industrial signature in frozen water at the top of the world, and we can now trace its economic history without touching a single Roman document. If you had asked a Roman smelter working in those Spanish hills whether his day's labour would still be detectable in polar ice, 19 centuries later he would have thought you were out of your mind. He was making silver. He was making a living. He was not leaving a message for anybody. But he left one anyway. I keep coming back to that man, honestly. He almost certainly could not write. Nobody recorded his name. He worked in conditions that would horrify any modern inspector breathing air that was slowly poisoning him, and when he died he was buried and forgotten within a generation. And yet the atoms he put into the sky are still sitting in Greenland, sorted neatly by year, more durable than every marble monument the empire ever raised to its emperors. That right there is the proof that this whole approach works. You do not need ruins. You do not need artifacts or writing or bones. A civilization that manipulates enough material at a large enough scale writes its own record into the environment whether it intends to or not. So why can we not simply do the same thing for the deep past? Because of a brutal simple limit, ice does not last. The oldest continuous ice anybody has pulled from Antarctica reaches back somewhere around 800,000 years. And a recent international effort pushed deeper still into ice that may be over 1 million years old. That is an extraordinary achievement, and it is also almost nothing. The event we spent our last stretch of this story discussing happened 56 million years ago. The age of dinosaurs ended 66 million years ago. Ice cores do not get us within 1/100th of the distance we would need, so the question becomes sharper and stranger. If we cannot use ice and we cannot count on finding bones or buildings, what exactly should someone be searching for in rock that is tens of millions of years old? There is a list. It is short, specific, and considerably more interesting than you might expect. The first item is nitrogen. Not the gas itself, but its isotopes, the slightly different weights of nitrogen atom that show up in different proportions depending on where the nitrogen came from. Every farm on Earth today runs on synthetic fertilizer produced by an industrial process that pulls nitrogen straight out of the air and forces it into a usable form. That process, invented at the beginning of the 20th century, is arguably the single reason our population grew the way it did. It also leaves a distinctive isotopic thumbprint in soils and sediments, because the nitrogen it produces is chemically different from the nitrogen that reaches soil through natural means. Any civilization that had to feed billions of individuals would have faced the same problem, and quite possibly reached for a similar solution. The second item involves metals, and here the search gets subtle. Certain elements are naturally rare in surface rock and abundant only in specific ores. An industrial society digs those ores up, concentrates the metals, uses them, discards them, and spreads them thinly across the surface of the world. Millions of years later, that shows up as an anomaly, not a lump of processed metal which would have corroded to nothing, simply a layer where certain elements appear in proportions that no natural process would produce. Think of it like a burglary where the thief takes nothing and leaves nothing but rearranges every piece of furniture in the house by a few centimeters. Nothing is missing, nothing is added, and yet a careful enough observer would know instantly that somebody had been inside. The third item is chemistry that should not exist. Nature builds an enormous variety of organic molecules, but there are entire categories of synthetic compounds that no biological process has ever produced. Some of them are stubbornly persistent, resistant to breakdown by heat, sunlight, or bacteria. Whether any of them can survive tens of millions of years of burial is an open question, and one of the specific research directions those two scientists recommended pursuing. The fourth item is the one that gives me a small chill every time I think about it. Certain radioactive elements do not occur naturally on Earth in any meaningful quantity. They are produced by nuclear reactions, and once they exist, they decay on their own schedule, indifferent to everything around them. One of them has a half-life of roughly 80 million years, which means that if a civilization somewhere in the deep past had ever split atoms at industrial scale, a faint whisper of that activity could conceivably still be sitting in the rock right now, ticking down, waiting for somebody with the right instrument to notice. Nobody has found such a thing. I want to be completely clear about that. But the fact that it is theoretically detectable across that kind of gulf of time is the sort of detail that makes this whole exercise feel less like a thought experiment and more like an actual, if very long-shot search. Let your breathing slow down here if it has not already. There is no urgency in any of this. Everything we are discussing has been sitting patiently in the ground for millions of years, and it will keep sitting there whether you stay awake for the rest of the story or not. There is one more category, and it is the one you can physically hold in your hand. In 2006, an oceanographer surveying a beach on the southeastern shore of the big island of Hawaii noticed something strange in the sand. The beach in question sits at the receiving end of a vast ocean current system, which means it collects an appalling quantity of drifting garbage from across the entire northern Pacific. It also sits about 12 kilometers from the nearest paved road, so visitors who make the trip tend to camp overnight and build fires on the sand. What he found were rocks that were not entirely rocks. Years later, a geologist and an artist travelled out to that same beach to study the material properly, and in 2014 they published a description of it in a geological journal. Campfires had been melting plastic debris directly into the porous volcanic stone and sand beneath them. The result was a genuine hybrid material, part basalt, part sediment, part polymer, fused into something new that had never existed on this planet before. They named it plastiglomerate, which I think is a wonderfully unglamorous name for the first rock type our species ever invented by accident. Here is why it matters geologically rather than just as a curiosity. Loose plastic is light. It floats, it blows around, it gets carried away and broken down. Plastic fused into volcanic rock is heavy. Heavy things sink into sediment and stay there. Heavy things get buried. Heavy things become part of the record. The geologist who studied it made a point that has stayed with me. If somebody came along a very long time from now and cut a cross-section through those layers, they would find a horizon of plastic sitting in the stone, and they would know, without any further evidence, that this was the moment a species on this planet made an enormous quantity of a material it did not know how to put away. The word for things like that in the technical literature is technofossils. A research team that made a first attempt to weigh everything our species has physically built, from buildings and roads to landfills and discarded electronics, arrived at an estimate somewhere around 30 trillion tons. If you spread that evenly, it works out to more than 50 kilograms of manufactured material for every single square meter of the planet's surface including the oceans. The same team estimated that the number of distinct types of manufactured thing now existing on this planet runs into the billions, which would make our species by a considerable margin the most prolific producer of distinguishable forms in the entire history of Earth. So let me put the question to you directly, and I am curious where your mind goes. If someone digging through rock tens of millions of years from now found nitrogen chemistry that made no sense metals in impossible proportions and a strange thin horizon of material no organism could have made, would you expect them to conclude that a civilization had existed, or would you expect them to spend 30 years arguing about volcanoes exactly the way we still argue about that ancient warming? I lean toward the second, and I suspect the two scientists behind this idea would agree with me. Absence of a neat explanation is not the same as evidence of anything. And there is a final twist to all of this one that I think is the most quietly profound point in the entire hypothesis. Everything on that checklist is a symptom of harm. The metal in the ice was pollution. The nitrogen signature is fertilizer runoff. The radioactive whisper would be fallout. Every single method we have of detecting a vanished civilization depends on that civilization having damaged its own planet badly enough to leave a scar, which means the better a civilization behaves, the more invisible it becomes. A society that found sustainable ways to produce energy, that recycled its materials properly, that never pushed its own atmosphere past the point of no return, would leave almost nothing for anyone to find. It could have existed for 100,000 years, built extraordinary things, understood the universe better than we do, and then faded out peacefully, and the rock would say absolutely nothing about it. There is something almost unbearably sad in that, and something hopeful too. The loudest signal any of us can send into deep time is the sound of a species in trouble, which flips the usual way of thinking about legacy completely on its head. We tend to assume that leaving a mark is the goal, that a civilization proves itself by how much of it survives. This suggests the opposite. The most successful civilization imaginable might be the one that leaves the future absolutely nothing to find, because it never broke anything badly enough to need remembering. Still, all of this rests on one assumption we have not questioned yet. We have been assuming an older civilization would have needed to burn something, that it would have dug into the ground for buried energy the way we did. And that raises a question with a surprisingly specific answer buried 300 million years deep. Or was there ever actually enough fuel down there early enough for anybody else to have found it first? Let me take you somewhere warm for a while, somewhere green and wet and frankly a little alarming. 310 million years ago, a swamp forest covers most of what will eventually become Pennsylvania, Ohio, and the coalfields of northern England. There is no grass anywhere, because grass has not been invented yet. There are no flowers, no birds, no mammals of any kind. What there is instead is water, endless standing water, black, and still threaded between the trunks of trees that look almost but not quite like anything you have ever seen. The trees are not really trees in the way you would recognize. They're giant relatives of the club mosses growing on forest floors today, some of them rising 30 meters or more with trunks covered in diamond-shaped scars where old leaves fell away. They grow fast, they die young, and they topple into the water in enormous numbers. The air itself is different. Oxygen levels during this stretch of Earth's history climbed considerably higher than the roughly 21% we breathe now, possibly as high as 35%. And that single change did something extraordinary to the animals. Insects breathe through a network of tiny tubes rather than lungs, which puts a hard ceiling on how large they can get. Raise the oxygen and you raise the ceiling. So flying through those swamps are dragonfly relatives with wingspans about the width of a dinner table, and crawling through the leaf litter are armoured millipedes long enough to stretch across a modern living room floor. If you could stand in that forest for 5 minutes, I suspect you would find the sound the most disturbing part. No bird song because there are no birds, no mammal chatter, simply the drone of enormous insects moving through air thick enough to burn. And that last point is not a figure of speech. With oxygen that high fire behaves differently, wet vegetation that would refuse to catch today would go up readily, and charcoal turns up in the rock from this period in quantities that suggest these swamps burned regularly and enthusiastically. A world with more oxygen is a world that is easier to set alight, which is a detail worth filing away because fire is going to matter a great deal before we are finished here. Now all of that is wonderful and strange, but it is not why this period matters for our story tonight. It matters because of what happened to the trees after they fell. Under normal circumstances, when a tree dies, it rots. Fungi and bacteria break it apart, the carbon locked inside goes back into the air and the cycle continues. In these swamps at this particular moment in Earth's history, an enormous quantity of that plant material did not rot. It piled up. It compressed. It got buried under the next layer and the next, and slowly over unimaginable spans of time it turned into coal. Not little coal. Most of the coal our species has ever burned came out of this window. The period is literally named for it. Carboniferous, the carbon-bearing age. And here is where it connects back to our question. The two scientists behind the hypothesis we have been following made a specific dated claim about this. From roughly 350 million years ago onward, they argued this planet has held enough buried fossil carbon to fuel an industrial civilization comparable to our own. Sit with the size of that window. 350 million years. Our own industrial era has lasted about 300. That means the fuel has been sitting there available to anyone clever enough to dig it up and set fire to it for roughly 1,000,000 times longer than we have been using it. So why did nobody else? Before we get to that, I want to deal with a story you have almost certainly heard because it is one of those explanations that is so satisfying it's spread everywhere, and it turns out to be mostly wrong. The story goes like this. Trees during this period had evolved a tough structural compound in their cell walls, and no fungus had yet evolved the ability to digest it. So dead trees just sat there undecayed for millions of years, piling up into vast graveyards of wood that eventually became coal. The imbalance ended only when fungi finally caught up, at which point the great coal-making age came to an end. It is a beautiful story. Nature caught with its guard down. 100-million-year gap between one invention and its counter-invention. I have seen it repeated in documentaries, textbooks, and more articles than I could count. The problem is that when a research team went back and examined the evidence, properly publishing their findings in 2016, the story fell apart in several places at once. For one thing, fossil wood from before and during this period shows clear signs of fungal decay. The fungi were there. They were eating. For another, the plants making up the bulk of those coal deposits were not especially rich in that tough compound to begin with. The material piling up was mostly a different kind of tissue entirely, and most damning coal accumulation rates stayed roughly similar across major shifts in which types of plants dominated the swamps, which should not happen if plant chemistry was the deciding factor. The researchers' conclusion was less romantic but considerably more interesting. The Great Coal Age happened because of a rare coincidence of geography and climate. The continents were in the process of colliding into one enormous landmass, and that collision created vast, low-sinking basins sitting right on the equator in a permanently wet tropical belt. Plant material fell into water and got buried before anything could finish eating it. Not because nothing could digest it, because it went under too fast. I bring this up not to be pedantic about fungi at bedtime, but because it illustrates something that keeps happening in this whole field. A neat, memorable explanation takes hold, gets repeated for decades, and quietly turns out to be a story we told ourselves because it was satisfying rather than because the evidence demanded it. I should be fair here, though. The scientist who first proposed that fungal explanation was doing perfectly reasonable work with the information available at the time, back when the fossil record of ancient fungi was thin and genetic dating methods barely existed. The failure was not hers. The failure, if there was one, belongs to the decades afterward, when the idea got repeated so confidently and so often that most people stopped treating it as a hypothesis at all and started treating it as a fact, which is, if you think about it exactly, the trap the hypothesis we are following is designed to help us avoid. Now the dinosaurs. Let me put the timescale on the table first, because most people underestimate it badly. Dinosaurs existed as the dominant land animals for roughly 165 million years. Our own species in anatomically modern form has been around for about 300,000. If you compress the entire reign of the dinosaurs into a single calendar year, all of human existence would occupy something under 16 hours. 165 million years is an enormous amount of time for evolution to experiment, so the question is not unreasonable. Did anything in that vast stretch ever come near intelligence of the kind that builds things? In 1982, a Canadian paleontologist named Dale Russell decided to find out what that might have looked like. Russell worked at a National Museum in Ottawa, and he had spent years studying a small, slender, sharp-eyed predator whose fossils turn up in North American rock from the final stretch of the dinosaur age. This creature had, by dinosaur standards, an unusually large brain for its body size, forward-facing eyes, suggesting good depth perception, and grasping hands with a degree of dexterity. Russell ran the numbers on how brain size had been trending in that lineage, extended the line forward, and then, together with a museum, taxidermists built a life-size model of what such an animal might have become if the asteroid had never arrived and evolution had kept pushing in that direction for another 66 million years. The result stood upright, had a large domed skull, three-fingered hands, and enormous eyes. The museum put it on display, and the reaction was immediate and divided. Some people found it fascinating. A great many paleontologists found it faintly ridiculous. I have seen photographs of Russell standing beside the thing, and there is something wonderfully awkward about them. A serious scientist in a serious institution posing next to a green humanoid that would not look out of place in a low-budget film. It took a certain amount of nerve to build it at all. The main criticism was, I think, entirely fair. Russell's creature looked suspiciously like a person. Same posture, same proportions, same general body plan, simply with scales instead of skin. Critics pointed out that this said far more about human imagination than about dinosaur biology. Birds are living dinosaurs, and some of them are startlingly intelligent, and none of them have shown the slightest tendency to stand upright and grow a domed forehead. Still, I have a soft spot for that model, and here is why. It was wrong in its specifics and right in its instinct. Russell was asking the same underlying question we're sitting with tonight. Is our particular shape, our particular path, the only route to a thinking creature that builds things? Or did we simply happen to be the branch that made it on a planet that had tried many others? Which brings me to a question I would like to hand to you. If you had to pick a species alive on Earth right now other than us that seems nearest to the threshold of building something, which would you choose? Most people say chimpanzees or dolphins or crows. My own answer is an octopus, and here is the cruel part. An octopus is extraordinarily clever, has 8 astonishingly capable limbs, can solve problems that defeat most mammals, and spends its entire existence somewhere it can never under any circumstances light a fire. That constraint is not a small one. Metallurgy requires fire, ceramics require fire. Every step on the road from stone tools to steam engines runs through combustion, and combustion does not happen underwater, which suggests that intelligence alone is nowhere near enough. You need a mind and hands and a dry place to burn something, and all three showing up in the same animal at the same time may be far rarer than any of us assume. There is a version of this constraint that applies to us as well, and it is worth naming. Our species spent something like 300,000 years being exactly as intelligent as we are now, anatomically identical with the same brains and the same hands, and for the overwhelming majority of that stretch we built nothing that would register in the rock at all. The intelligence was never the bottleneck. Something else had to line up. Agriculture, surplus population density, and eventually the specific accident of somebody working out how to turn buried carbon into rotational motion. Run that same arithmetic on any other lineage, and the odds start looking brutal. A species could be brilliant for 10 million years and still never cross the line. Rest here a moment if you would like. Let the images go soft. None of this needs holding on to. So what is the honest verdict on the dinosaurs? Almost every working paleontologist would tell you no, and their reasoning is not simply a hunch. The fossil record from certain intervals of the dinosaur age is remarkably dense. We have thousands of specimens from many continents across many environments. We have nesting sites, trackways, stomach contents, growth rings in bone. None of it shows anything resembling tool manufacture-controlled fire, permanent settlement, or the ecological footprint that a technological species leaves behind. But there is one argument I find more persuasive than all of that, and it is almost embarrassingly simple. The coal is still there. Think about it. If some earlier civilization had reached an industrial stage, the first thing it would have done as we did is find the easiest, richest, most accessible energy in the ground and burn it. Surface coal seams, shallow oil, the low-hanging fuel. And we found all of that sitting untouched in exactly the places geology predicted it should be when our own species came along and started digging. Somebody got there first, and it was us. I keep turning that over because there is something almost lonely in it. Every seam of coal we have ever opened, every oil field we have ever tapped was untouched when we found it. 350 million years of stored sunlight sitting in the dark, and not one thing had ever come along to spend it. Whatever else that tells us about the deep past, it tells us something about how unusual this particular moment is. That is not absolute proof, and I want to be careful here. A civilization on a different continent, or one that never scaled up to global industry, or one whose deposits were consumed and then replenished across hundreds of millions of years, would not necessarily show up in that reasoning. But as a piece of evidence, I find it quietly powerful. The fuel tank was full when we arrived. So the honest position at the end of all this sits somewhere uncomfortable. There was enough fuel for long enough that it could have happened. There is no evidence at all that it did, and the record is patchy enough that the absence of evidence carries less weight than we would like it to. That is where a careful scientist stops. The trouble is that is precisely the point where a great many other people do not stop at all. Because a question this strange framed this openly is an absolute gift to anyone selling a much more exciting story. And the moment a serious paper about detection limits in the sedimentary record escaped into the wider world, it collided with an entire industry of vanished continents, ancient astronauts and civilizations that supposedly built the pyramids before the last ice age. Which means we now need to do something delicate. We need to work out exactly where the science ends and where the storytelling begins. Athens somewhere around 360 years before the Common Era. An old man is writing. Plato is in his 60s by now, running a school on the outskirts of the city, and he has been turning over a problem that has nothing to do with geology and everything to do with politics. He wants to argue something about how states behave, about arrogance and decline, about what happens to a society that grows powerful enough to stop questioning itself. Philosophical arguments are hard to sit through, stories are not. So Plato does what good teachers have always done. He builds a fiction to carry the point. He describes an island power beyond the pillars at the edge of the known world. Enormous, wealthy, technologically advanced, ruling an empire across the sea. He gives it concentric rings of water and land harbours, temples a system of canals. He makes it beautiful, then he makes it corrupt, and then in the space of a single terrible day and night, he sinks the entire thing beneath the waves. He's careful about how he frames it too. The story does not come from him directly. It arrives third-hand, told by a character who heard it from his grandfather, who heard it from a famous lawmaker, who supposedly heard it from priests in Egypt. 4 layers of hearsay before you reach the actual claim. Any listener in that room would have understood exactly what that framing signals. There are other tells if you go looking. The dates Plato gives are enormous, placing the island 9,000 years before his own lifetime, which in the ancient Greek imagination was less a real number than a way of saying unimaginably long ago. The geography is schematic and perfectly symmetrical, laid out in tidy concentric circles, which is how a philosopher draws a diagram rather than how a real coastline ever behaves. And the moral arrives precisely on schedule the way morals do in stories and never do in history. And here is the detail I find most telling of all. Plato started writing a second dialogue to continue the story, went partway through, and then simply stopped. The text breaks off in the middle of a sentence. He never went back to finish it. Whatever he needed the island for, he had already gotten it. That is the entire original source. One philosopher, one unfinished argument 24 centuries ago. No earlier text anywhere in the ancient world mentions this place. Not one. And Plato's own most famous student is said to have dismissed the whole thing with a line that historians still quote, to the effect that the man who invented the island was also the man who sank it. So how on earth did a teaching device turn into an industry? For that we have to jump forward more than 2,000 years to a politician from Minnesota. Ignatius Donnelly served in the House of Representatives, lost his seat, and reinvented himself as a writer of extraordinarily ambitious books. In 1882, he published a work arguing that Plato's island had been entirely real, that it had been the mother civilization of the whole world, and that everything from Egyptian pyramids to Mesoamerican temples to European mythology descended from its survivors. The book was a sensation. It went through edition after edition and reached an audience that no scholarly text could dream of. Nearly every modern claim about a vanished global civilization traces back one way or another through that one 19th century volume by a failed congressman with a talent for pattern matching. And I want to be careful not to sneer at him, because Donnelly was not a fraud. As far as anyone can tell, he believed every word. He worked hard, he cited sources, he truly believed he had found something enormous. His problem was not dishonesty. His problem was that he started with an answer he found beautiful, and then went looking for a world that fit it, and the human mind is disturbingly good at obliging that request. Similar-looking pyramids on two continents becomes proof of contact rather than proof that piling stones into a stable shape has a limited number of solutions. A flood story here and a flood story there becomes a shared memory, rather than the obvious fact that most human settlements are near water, and water occasionally rises. That habit of mind is not confined to the 19th century, and it is not confined to cranks. It is a default setting in all of us, and staying alert to it is most of what separates careful thinking from confident nonsense. Which brings us to the awkward question at the heart of this stretch of our story. If two respected scientists can publish a paper asking whether an industrial civilization existed on Earth before us, and that question is treated as legitimate, what exactly separates it from the pile of books promising lost continents and forgotten empires? It is a fair question. And I think the answer is precise enough to be worth walking through carefully, because once you can see the difference, you can apply it to almost anything. The first test is what the claim actually asserts. Those two researchers never claimed a previous civilization existed. Their entire paper is about detection, about limits, about what our instruments and our rocks can and cannot tell us. The whole exercise runs in the opposite direction from a lost empire narrative which starts with a conclusion and then hunts for supporting scraps. The second test is whether the idea can fail. A real hypothesis has to be capable of being wrong. The paper we've been following makes specific testable proposals. Go find sediment layers from certain eras. Measure these particular isotope ratios. Search for these specific classes of compound. Every one of those investigations could come back with a flat, boring no, and the researchers would accept it because a negative answer is still an answer. A story about a sunken continent, by contrast, tends to survive every disconfirmation. No ruins on the seafloor, the ocean swallowed them. No genetic trace in surviving populations, the survivors interbred too thoroughly. No written records, all destroyed. Notice what's happening there. Every piece of missing evidence gets converted into further proof. That is not a hypothesis. That is a machine for turning silence into confirmation. There is a name for that structure, and it applies far beyond archaeology. A claim that cannot lose is a claim that cannot teach you anything. If no possible observation would change your mind, then your position is not really about the world at all. It is about you. The third test is what happens to the claim under pressure. Good science gets more specific when challenged. Someone raises an objection and the response is a number, a measurement, a sample, a refinement. Weak claims do the reverse. Push on them and they become vaguer, older, more mysterious, always retreating another few thousand years into a period where nobody can check. Now, I want to be honest with you about something, because painting this as a clean line between virtuous science and obvious nonsense would be dishonest. The boundary is not a wall. It is a wide, uncomfortable, frequently bad-tempered zone, and there are ideas sitting right in the middle of it. Consider one that has generated some of the fiercest arguing in Earth science over the past 2 decades. Around 12,900 years ago, the Northern Hemisphere plunged abruptly back into cold conditions in the middle of what should have been a steady warming trend out of an ice age. That much is completely uncontroversial. It happened, it is well dated, and it changed a great deal about the world. In 2007, a research group proposed that the trigger was an impact or airburst from space, and pointed to a set of microscopic markers they had found at sites across several continents. Tiny spherules, nanodiamonds, unusual concentrations of certain rare metals. What followed was not a fringe pamphlet war. It was a genuine scientific fight conducted in mainstream journals with credentialed researchers on both sides. In 2023, a large team published an enormous review paper arguing the idea had been comprehensively refuted, noting, among other things, that no crater of the right age has ever been found. The other side responded with rebuttals, and then rebuttals to the rebuttals, and the exchange has continued right up to this year. I'm not going to tell you who is right, because I have no business doing so, and neither does anyone who has not spent years with the actual samples. What I want you to notice is the shape of the disagreement. Both sides publish, both sides cite evidence, both sides make claims that could in principle be settled by future fieldwork. That is what a real controversy looks like, and it is messy and slow and frequently ill-tempered, and it is nothing at all like a book promising you a hidden empire. So here is what I would put to you, and I'm curious how you would answer it. When you encounter a strange claim about the ancient past, what is your own personal test? Do you look at the evidence or at who is making the claim, or at whether they are selling something? I suspect most of us use a mixture, and I suspect most of us are not entirely aware of which one is doing the heavy lifting. Settle in a little deeper here. There is nothing in this section that requires effort from you. Let it wash past if it wants to. There is one more thing I want to say about lost civilization stories, and it is the part I feel most strongly about. These narratives are not harmless. Throughout the 19th and 20th centuries, a recurring pattern shows up in how outsiders explained impressive ancient structures they encountered. When a monument was found in a place where the explaining party did not expect sophistication, the explanation frequently became somebody else built this. Refugees from a lost civilization, visitors from elsewhere, anyone but the people whose ancestors actually built it. The clearest case I know sits in southern Africa. There is an enormous stone complex with walls rising many meters high, built entirely without mortar, containing a conical tower and a great enclosure that remains one of the most impressive structures anywhere on that continent. It was built by ancestors of the local population beginning around the 11th century, at the heart of a wealthy trading kingdom connected to the Indian Ocean world. For decades, colonial-era authorities insisted this could not be true. They proposed Phoenicians, Arabs, refugees from Plato's island, almost anyone else. When a British archaeologist conducted a rigorous excavation in the late 1920s and concluded firmly that the site was of local African origin, her findings were resisted, and for years afterward the government of the territory actively discouraged museums and guidebooks from stating the truth plainly. That is not an abstract harm. That is a real theft from real people of a real achievement, and the damage outlasts the lie. Generations of visitors were told a false story about that place. Generations of local school children grew up in a country whose official position was that their own ancestors could not have built the greatest monument standing on their own soil. Correcting the record took decades, and in some corners of the internet the false version is still circulating several human lifetimes after the archaeology settled it. And it is why I think the careful version of this question matters so much. The scientists asking whether Earth hosted an industrial civilization 60 million years ago are not taking credit away from anybody. There were no humans then. There is nobody to erase. The question is aimed at a stretch of deep time so remote that it belongs to no culture at all, which is precisely what makes it safe to ask. Contrast that with any claim about lost builders of the pyramids, or the great earthworks of North America, or the stone cities of the Andes. Every one of those claims takes something away from a specific group of human beings who did something remarkable and left their descendants behind to be told later that they were not capable of it. Now, I do not want to end this stretch sounding like a scold, because there is a version of this instinct that I find lovely. The desire to believe in a lost golden age is one of the oldest and most human things there is. It shows up in ancient Greece, in Mesopotamian flood stories, in the mythologies of cultures that had no contact with one another. Something in us keeps reaching backward for a time when things were grander, wiser, more whole. I suspect it has less to do with archaeology, and more to do with being a creature that knows it is going to die, and would prefer to believe that greatness is at least possible somewhere. The question we have been circling all night takes that ancient longing and does something unusual with it. Instead of answering it with a story, it answers with a method. Instead of promising you a sunken empire, it hands you a list of measurements and says, go and check. That is, I think, the most respectable thing anybody can do with a wild idea. Not suppress it, not sell it. Simply insist that it earn its place. And I would gently suggest that the same standard is worth carrying out of this story and into the rest of your week. Not as cynicism, which is just laziness wearing a serious expression, but as a kind of hospitality towards strange ideas. Let them in. Offer them a chair. Then ask them politely what they would accept as proof that they are wrong. Which leaves us with an uncomfortable practical problem, and it is the one the two authors of that paper flag themselves. Every method we have discussed depends on rock that stays where you left it, and we have already established that this planet is terrible at that. It grinds, it melts, it recycles, it erases. So the obvious next thought is almost embarrassingly simple once somebody says it out loud. If Earth is such an unreliable witness, why are we only searching Earth? There are other surfaces in the solar system, quiet ones with no oceans to swallow anything, no weather to wear it down, and no tectonic engine grinding the past back into the furnace. And some of them have been sitting there undisturbed since long before the dinosaurs. Picture a single footprint. It was made on the 20th of July 1969 in a flat grey plane of powder finer than talc. The boot that made it belonged to a man from New Jersey, and the print itself is unremarkable in every way except one. It is still there. Not preserved, not protected, not maintained by anybody. Simply still there exactly as it was pressed into the dust more than half a century ago, sharp-edged and perfectly legible. Because the place where it sits has no air to disturb it, no rain to soften it, and no living thing to walk across it. There is a photograph of that print, and I would encourage you to look it up sometime when you are awake enough to appreciate it properly. What gets me about it is not the heroism, it is the stillness. That impression in the dust will outlast every city on this planet. It will very likely outlast our species. Estimates vary, but most researchers reckon that constant bombardment by microscopic particles from space will take somewhere between 1 million and 10 million years to erase it, which is a stretch of time so long that our entire recorded history would fit into it hundreds of times over. I find that comparison difficult to hold in my head, so let me put it another way. Every pyramid, every cathedral, every monument our species has ever built to make itself remembered is currently losing a slow argument with weather. The most durable thing we've ever made was made by accident in about 1 second by a man in a bulky suit who was mostly concerned with not falling over. Now hold that thought and consider what it implies. Everything we have discussed tonight has been a story about a planet that refuses to keep records. Earth grinds its own surface back into the furnace. It buries chapters under mountains. It dissolves shells, folds rock, and hands us a history with most of the pages torn out. But Earth is not the only surface in this solar system. And that observation, obvious as it sounds, once someone says it plainly is the foundation of one of the strangest and most quietly thrilling scientific papers I have come across. In 2018, an astronomer named Jason Wright published a short piece in the same journal that had carried the hypothesis we have been following all night. Wright works at a university in Pennsylvania, and he spends most of his professional attention on the search for signs of technology elsewhere in the universe. His paper carried a wonderfully dry title, something along the lines of Prior Indigenous Technological Species, which is academic language for a considerably more startling idea. His argument runs like this. For decades, anyone hunting for alien technology in our solar system has assumed that any such technology would have arrived from somewhere else. Another star system, some distant civilization sending probes. But there is one location where we already know for a fact that life arose and where it has been developing continuously for billions of years. Right here. So if a technological species ever emerged in this solar system before us, and if it ever managed to leave its home world even briefly, the evidence would not necessarily be sitting under Earth's restless crust at all. It might be sitting somewhere considerably quieter. Wright was scrupulous about this, and I want to be equally scrupulous in passing it along. He stated flatly in interviews at the time that there is zero evidence for any such prior civilization. Zero. His paper was not a claim. It was an argument about where a search would make sense if anybody wanted to conduct one properly. And the logic of where to look is beautiful. Start with our own moon. It has no atmosphere worth mentioning, which means no weather, no erosion by moving air, no rain. It has no liquid water. It has no plate tectonic, so its surface does not get dragged down and remelted the way ours does. Some of the terrain up there has been sitting essentially undisturbed for around 4 billion years. Think about what that means for a moment. When you look up at the moon tonight, you're looking at a surface older than almost anything on Earth. The face it shows us has been watching this planet since before the first cell divided down here. It saw the oceans form. It saw the continents assemble and break apart again. It has been there for every single thing that has ever happened on Earth, and unlike Earth, it has not thrown any of it away. There is a detail here that I find almost unbearably poetic. When a large asteroid strikes Earth, it blasts material off the surface at enormous speed. Some of that material escapes the planet entirely, and a fraction of it over billions of years has landed on the moon, which means that the lunar surface should contain pieces of ancient Earth. Rocks from eras our own planet has long since recycled into nothing. This is not speculation. In 2019, a team analysing a sample brought back by one of the later Apollo missions reported that a fragment inside it appeared to have formed under conditions typical of Earth, rather than the moon, and dated to roughly 4 billion years ago. The finding has been debated ever since, as findings of that kind always are. But the underlying principle is sound and widely accepted. The oldest surviving pieces of our own world may not be on our world at all. Let that settle for a second. We have spent this entire night discussing how thoroughly Earth erases its own past, and it turns out Earth may have been quietly mailing copies of itself to a storage facility 250,000 miles away the entire time by accident. Geologists have started taking this seriously enough to give it a name and a plan. If you wanted to find rock from the earliest chapter of Earth's history, The chapter our planet has entirely destroyed, the most promising place to dig might be the lunar soil. Not because anything interesting happened up there, because the moon has been catching our debris for 4 billion years and, unlike us, never bothered to clean the shelf. Now let me take you somewhere stranger. Everyone's instinct when this subject comes up is to think about Mars, and Mars is a reasonable place to think about. It had liquid water once running in rivers and pooling in lakes 3 to 4 billion years ago. It has no plate tectonics either, which means ancient terrain survives on its surface in a way that would be impossible here. If anything ever happened on early Mars, the ground there has a far better memory than ours. There is a catch though, and it is worth naming. Mars is not entirely still. It has dust and it has storms that can wrap the whole planet for weeks at a time, and over billions of years that dust has buried, uncovered and reburied enormous stretches of terrain. It also has no magnetic shield worth speaking of, which means the surface is soaked in radiation that breaks down complicated molecules over time. Anything delicate resting on the surface of Mars has had a rough few billion years, which is precisely why the astronomer we have been following suggested that a serious search should look underneath rather than on top. But the planet that keeps me up at night is the other one. Venus is today the most hostile place in the inner solar system. Surface temperatures hot enough to melt certain metals. Atmospheric pressure equivalent to being nearly a kilometre underwater. Clouds of acid. It is by any reasonable description a furnace. It may not always have been. Modelling work done in recent years, including at the very same Climate Institute where one of the two authors of our main story works, has suggested that Venus could have held liquid water and moderate surface temperatures for an extraordinarily long stretch, possibly for billions of years before something went catastrophically wrong. Depending on which model you trust, that pleasant period may have persisted until as recently as several 100 million years ago. And then Venus did something almost no other planet we know of has done. Its entire surface appears to have been resurfaced. Volcanic activity on a scale that is difficult to imagine, repaving the whole world, erasing everything that had ever been on it. So here is a question worth sitting with in the dark. If a world in this solar system spent 2 billion years with oceans and a temperate climate, and then had its entire surface wiped smooth and rewritten in lava, what would we ever be able to say about what happened during those 2 billion years? Nothing. We would be able to say nothing at all. That is not evidence of anything. Nobody is claiming Venus had cities. But as a demonstration of how completely a planetary record can be destroyed, it is unmatched, and it sits 90 million miles from where you're lying right now. There is a version of this idea that I find quietly haunting, and I want to be clear it is nothing more than a thought. Somewhere in this solar system there may be a planet that spent longer being pleasant than Earth has spent having animals on it at all, and we will never know a single thing about what filled those years. Not because the answer is hidden, because the page was burned and then the ashes were paved over. Take a slow breath here if you want one. Nothing about this requires urgency. The moon has been waiting 4 billion years. It can wait a little longer. Now before this starts sounding too much like a treasure map, let me be honest about how difficult any such search would actually be. The surface of the moon covers roughly 38 million square kilometres. That is a bit larger than the entire continent of Africa. Human beings have physically walked on an area of it that, added all together across every crewed landing, amounts to something less than a moderately sized town. Our best orbital cameras can resolve features down to about 0.5 meter per picture element, which sounds impressive until you realise what it means practically. We can spot the equipment left behind by our own missions, because we know precisely where to look and precisely what shape to expect. We could not spot something a metre across in an unexpected place, and we certainly could not spot anything buried, which is exactly where Wright suggested a search should focus, because anything sitting exposed on the surface for hundreds of millions of years would be pulverized by the same slow bombardment that will eventually erase that footprint. So the honest position is this. There are surfaces in this solar system that keep records far better than Earth does. We have examined an almost comically small fraction of them, and the absence of any discovery so far tells us almost nothing, because we have barely started looking and we have not been looking for this. Which raises a question I would like to put directly to you, because I find my own answer changes depending on my mood. If a proper search were funded and conducted carefully across the Moon and Mars and the outer solar system and it came back with absolutely nothing, would that satisfy you? Would you file the question away as answered? Or would some part of you keep wondering whether we simply looked in the wrong places the way people always do when a search for something extraordinary comes up empty? I ask because that is the hardest problem in this entire field. A negative result never quite feels like a result. And a discipline that cannot accept a no has a serious problem on its hands. For what it is worth, I think the honest answer is that a thorough search coming back empty would still be worth every penny. Not because it would settle the question, but because we would have looked properly at the surfaces nearest to us for the first time, and along the way we would have learned an enormous amount about them. Almost every great scientific search has produced its most valuable findings sideways, while hunting for something else entirely. There is one more thought I want to offer before we move on, and it is the one that stays with me longest. We tend to think of the moon as scenery. Something pretty that shows up in the evening sky, useful for tides and poetry and not much else. But if the reasoning we have followed tonight holds that grey, cratered, silent thing hanging above your roof, right now might be the single most complete historical archive available to our species. Not because anything happened there, because nothing did. It is a hard drive with no delete function orbiting a planet that has been overwriting itself since the day it formed. And that thought, I think, quietly changes something about looking up. The next time you find yourself outside at night and the moon is out, you're not simply looking at a rock. You're looking at the only witness to Earth's entire history that never threw its notes away. It watched everything. It kept everything. And it has never once been asked a single question about any of it, which brings us in the most uncomfortable way possible back around to ourselves. Because if the moon really is keeping a record, then it is keeping one of us too. That footprint is already a part of the archive. So are the vehicles, the instruments, the discarded equipment, and the several tons of material our species has left scattered across a world we visited briefly and then stopped visiting. We have spent this whole night asking what somebody else might have left behind for us to find. It seems only fair to turn the question around now and ask what exactly we are leaving behind, and how a geologist arriving 60 million years from now would interpret the strange, thin, glittering layer that our brief moment on this planet is currently pressing into the rock. So let me ask you something that sounds like a joke and is not one at all. What do you think the defining fossil of our era will be? Take a second with it. Most people reach for something dignified, a skyscraper, a bridge, maybe a spacecraft if they are feeling optimistic. One or two might say a smartphone. The most serious scientific answer anyone has put forward is a chicken bone. I want to walk you through why, because the reasoning is airtight and slightly devastating. In 2018, a research team based mostly in the English Midlands published a study that asked a simple question. If a paleontologist arrived on this planet in the far future and started digging what single species would jump out at them as the signature of our moment, their answer was the modern meat chicken, and the numbers behind it are hard to argue with. At any given instant, there are somewhere over 20 billion of these birds standing on this planet. Not over a year. At once. That makes the chicken, by an enormous margin, the most numerous bird species that has ever existed, and quite possibly the most numerous land vertebrate in the entire history of Earth. But abundance alone is not what makes something a marker fossil. What makes it a marker fossil is being different distinctly and abruptly from everything that came before. And the modern meat chicken is different. Its ancestor was a jungle bird from Southeast Asia, domesticated something like 8,000 years ago, roughly the size and shape of a pheasant. What sits in a supermarket cooler today is a creature with a completely reshaped skeleton, growing at a rate that would have been biologically impossible for its own great-grandparents with bone chemistry that carries the isotopic fingerprint of an industrially manufactured diet. That transformation did not take millions of years. It took a few decades beginning in the middle of the 20th century, driven by a deliberate breeding push that was no exaggeration. Marketed at the time as a program to build the chicken of the future, it worked in the narrow sense that such programs usually work. Growth rates soared, individual body mass climbed several times over within living memory. An industry that had been scattered across countless small farms consolidated into an integrated system that now handles nearly the whole supply, in some countries from hatchery to supermarket shelf. And in doing so without anyone intending it, our species performed something no other creature has ever managed. We produced a brand new distinguishable skeleton deliberately in under a human lifetime, and then distributed it to every inhabited continent on Earth simultaneously. So picture the far future paleontologist. They cut into a layer of rock, and in that layer across every continent on Earth, appearing at essentially the same instant geologically, is an enormous quantity of bones belonging to a bird that does not resemble anything in the layers below it. That is a textbook marker species. It's exactly the sort of thing our own scientists use to define boundaries between geological periods. And we're producing it right now at a rate of billions per year and throwing the bones into holes in the ground. The geologist who headed that study made a point I keep coming back to. The modern chicken, she said, is essentially unrecognizable compared to its wild counterparts. Body size, skeleton shape, bone chemistry, genetics, all distinct. Which means the fossil that defines our age will not be a monument to our ambition. It will be a record of our appetite. There is a bleak comedy in that, and I do not think we should look away from it. Every civilization imagines its legacy will be its cathedrals. Ours may well be the leftovers. Now let me widen the lens, because the chicken is only the most vivid item on a long list. Start with the single most manufactured material in human history. Not steel, not plastic, concrete. We have produced so much of it that estimates suggest there is now roughly enough to lay a kilogram over every square meter of the planet's entire surface, oceans included. Concrete does not rot. Buried under sediment, it behaves rather like a sedimentary rock, which is essentially what it is, and it will survive burial for an extremely long time. Then consider a metal that in its pure form barely exists in nature at all. Aluminum is one of the most abundant elements in Earth's crust, but it is almost never found as a shiny metal because it bonds ferociously with oxygen. Producing it requires enormous quantities of electricity, which is why almost nothing made of aluminum existed before the 20th century. Effectively, every piece of metallic aluminum on this planet was made by us. Hundreds of millions of tons of a substance that, geologically speaking, simply was not here before, and which resists corrosion beautifully once buried. I love that example because it is such a quiet one. Nobody thinks of a drink can as a historical artifact. And yet a drink can is in the strictest sense an impossible thing. It could not have existed at any point in the previous 4.5 billion years of this planet's history, and it will still be recognizably itself long after the person who drank from it is forgotten. Then there is the sheer physical rearranging of the surface. Our species now moves more rock and soil around this planet through mining, construction and agriculture than all the rivers on Earth combined. Think about the scale of that for a moment. Every river, every flood, every landslide on every continent added together, and we outweigh them. We are by measurement rather than metaphor the dominant erosional force on the surface of this world. There is a strange dignity in that fact, and also something faintly absurd. No individual person has ever felt like a geological force. Nobody digging a foundation or driving a truck or ordering a delivery has ever experienced themselves as the equal of the Mississippi. And yet added together 8 billion of us shifting small amounts of material for entirely ordinary reasons have quietly become the largest earth-moving process operating on this planet. Which brings us to what I think is the most durable thing we have ever made, and it is not what you would guess. It is not our buildings. Skyscrapers fall over. Steel corrodes. Glass shatters. Give a modern city a few thousand years without maintenance, and the visible part becomes rubble, then soil, then nothing. What survives is what we dug. Foundations, tunnels, subway systems, sewers, mine shafts running 4 kilometers straight down into the crust. Those are not structures sitting on the surface waiting to be worn away. Those are holes in bedrock, and holes in bedrock fill with sediment and become permanent features of the rock itself. A geologist in the deep future would not find our cities. They would find the negative impression of our cities. Ghost outlines where something had once been dug and then filled back in, arranged in patterns no natural process would ever create. That is a properly eerie thought, and I mean it kindly. Everything you can see of a city is temporary. Everything underneath it is very nearly eternal. Rest here if you need to. Nothing about this is urgent, and none of it is happening tonight. Now, if you have been paying attention, you may have noticed something strange about that entire list. Not one item on it is information. We have spent this whole night talking about what a civilization leaves behind, and every single durable marker turns out to be a byproduct. Waste, bones, poured stone, rearranged dirt. The things we would most want a future observer to find: our music, our mathematics, our languages, our histories, our arguments about what any of it means, are stored almost entirely on media that will not survive a single century without active maintenance. Magnetic drives degrade in years. Optical discs cloud over in decades. Every piece of digital information our species has produced sits on hardware that requires a functioning civilization to copy it forward over and over forever, or it simply stops existing. Which produces one of the strangest facts about our moment. We are without question the best documented generation in human history. We are also quite possibly the most fragile one, because a written record on clay from 4,000 years ago is in better long-term shape than a photograph taken last week. Somebody in ancient Mesopotamia pressed a wedge into wet clay to record a delivery of barley, and we can still make out what it said. A person in the 20th century saved their family films onto tape, and their grandchildren already cannot play them. Durability, it turns out, has almost nothing to do with sophistication. Frequently it runs the other way. So here is the question I would like to hand you, and I suspect it will follow you into sleep whether you want it to or not. If you could add one thing to the geological record on purpose, knowing it would be found 60 million years from now by something that has never heard of us, what would you choose? Not what would be useful. What would you want them to know? I've gone back and forth on my own answer for years and never settled it. Some days I think it should be a piece of music. Other days I think it should be a warning. There is one more part of this story worth telling, and it involves an argument that most people never heard about. For roughly 15 years, a working group of scientists studied whether our impact on this planet had become large enough to justify declaring a new chapter in the official geological timescale. This is not a symbolic exercise. The timescale is a formal structure governed by strict rules, and adding a new unit to it requires identifying a physical location in rock or ice or sediment, where the boundary can be pinned down precisely. In 2023, after considering candidate sites around the world, the group selected a small deep lake in southern Ontario. What makes it remarkable is its shape. It is unusually deep relative to its surface area, which means the water at the bottom never mixes with the water at the top. Sediment settles there in undisturbed annual layers like tree rings made of mud, and the layers from the middle of the 20th century show an unmistakable shift in chemistry. It was by all accounts an elegant choice. A single small body of water in Canada chosen to stand for the moment an entire species became a planetary force. And then in early 2024, the broader scientific body responsible for approving such things voted it down. The reasoning was not that our species has failed to change the planet. Almost nobody disputes that. The objection was technical and I think defensible. A geological epoch is normally a unit of substantial duration, and defining one that began around 1950 means declaring an epoch shorter than a single human lifetime. Some argued the changes we have caused are better described as an ongoing event, rather than a bounded chapter in the way that the Great Warming we discussed earlier is an event rather than an epoch. The decision caused a fair amount of public frustration, some of it, from people who took it as scientists denying the seriousness of what is happening. That interpretation is wrong, and the distinction matters. Nobody voted that our impact is small. They voted that a particular filing system was not the right place to record it. I find the whole episode oddly reassuring, honestly. It is a group of specialists refusing to bend their own rules for a conclusion almost all of them personally agree with. That is not stubbornness. That is exactly the discipline that makes the rest of their work trustworthy. But it leaves us in a peculiar position. Our species has measurably altered the chemistry of the atmosphere, the composition of the oceans, the biology of the most abundant vertebrate on land, and the movement of sediment across the entire planet, and the official record of Earth's history does not yet have a name for the moment we did it. The rock will remember anyway. The rock does not require a vote, and whatever we're laying down right now, it will be thin. That is the detail that stays with me longest. Everything we have discussed, the chicken bones and the concrete and the aluminum and the isotopes and the rearranged mountains, will compress into a layer you could cover with your hand. A stripe a few centimeters thick, if that. Something a future geologist might scrape past without pausing the way we scrape past so much else. I want to be careful about how that lands because it can sound like despair, and I do not intend it that way at all. A thin layer is not the same as a meaningless one. The boundary that marks the end of the dinosaurs is also thin, a few centimeters of clay in most places, and it is arguably the most studied stripe of sediment on this planet. Thinness is not insignificance. It is simply what happens to any amount of activity when you compress it against enough time. What makes a layer matter is not how thick it is. It is whether anybody arrives who is curious enough to ask what made it. Unless, of course, they are looking for exactly that kind of stripe, because they have already asked themselves the same question two scientists asked in a quiet office one evening. Whether anybody came before, which leaves one question standing, and it is the largest one of the night. If a civilization did rise here once or on any of the countless worlds circling the stars outside your window, then something happened to it. Something ended it, or hid it, or stopped it from ever getting far enough to be seen. And the shape of that answer might tell us rather a lot about what happens next to us. The most important question in this entire field was asked over lunch by accident by a man who was not even trying to be serious. Summer of 1950. A dining hall on a high dry plateau in New Mexico at a laboratory that had spent the previous decade doing work its staff still could not discuss outside those walls. 4 physicists are walking over for their midday meal, and they are talking about something silly. A magazine had recently run a cartoon showing aliens climbing out of a flying saucer, cheerfully carrying away municipal trash cans. It was a joke about a spate of missing bins in New York City, tied to the flying saucer stories that were everywhere in the newspapers that year. The physicists found it funny, and the conversation moved on to whether faster-than-light travel might ever be possible, and then, as conversations do, drifted somewhere else entirely. I love that this is the actual origin. Not an observatory, not a conference. 4 men who had recently helped change the 20th century walking to lunch, laughing about a cartoon involving stolen garbage cans. They sat down, food arrived. The subject had been dropped for some time, and then out of nowhere in the middle of an unrelated conversation, Enrico Fermi looked up and asked more or less, "Where is everybody?" Everyone at the table understood him immediately. That is the remarkable part. He had not explained the question. He didn't need to. All 4 of them had been quietly running the same arithmetic in the backs of their minds, and they all knew what he meant. One of the men at that table wrote down his recollection of the afternoon decades later, which is the only reason we have any detail at all. He remembered Fermi then doing something very characteristic. He started estimating out loud on the spot. How many stars might have planets? How many planets might develop life? How long a civilization might last? Rough numbers pulled from the air the way a certain kind of physicist does when he wants to know whether a question is worth taking seriously. It is worth noting that this happened a full decade before anyone wrote a proper equation for it. Fermi did the whole thing between courses. Here is the arithmetic. This galaxy contains somewhere between 100 and 400 billion stars. It is roughly 13 billion years old, which means it has been assembling stars and planets for nearly 3 times as long as our own sun has existed, and it is about 100,000 light years across, which sounds enormous, and is until you compare it to the age. Suppose a civilization somewhere out there decided to spread. Suppose it did so terribly slowly, using nothing faster than the kind of technology we can already imagine building. Even at that crawl, the mathematics keeps producing the same uncomfortable result. A determined species could cross this entire galaxy in a few million years, maybe a few tens of millions if it took its time. A few tens of millions of years in a galaxy that has been running for 13 billion, which means that if anybody, anywhere, at any point in the last several billion years had wanted to fill this galaxy with their descendants, they would have had time to finish the job hundreds of times over before our own sun even formed. So where is everybody? That question has hung over astronomy ever since, and I want you to notice something about it that usually goes unremarked. It is exactly the same question we've been circling all night, simply pointed outward instead of downward. We have spent this whole evening asking whether anyone came before us on this planet. Fermi was asking whether anyone came before us in this galaxy. Same silence, same absence of evidence, same difficulty telling whether the emptiness is real or whether we are simply bad at noticing. Which is presumably why, a year after publishing the paper that started this whole story, one of its 2 authors turned around and went after Fermi's version of the question directly. In 2019, a small group published a modelling study on exactly this problem. The team included the astrophysicist from Rochester, whose late-night conversations began this entire night, along with the astronomer from Pennsylvania, who argued for searching the moon, and 2 colleagues, which I find rather satisfying. The same handful of people circling the same silence from 3 different directions. Their paper did something that sounds obvious in hindsight and had almost never been done properly before. Every previous attempt to model how a civilization might spread across a galaxy had treated the stars as if they were nailed in place, fixed points on a map. You launch from one, you arrive at the next, you launch again, and the distances stay what they were. But stars are not fixed, stars move. Our own sun is currently travelling around the centre of this galaxy, at roughly 230 kilometers per second, dragging every planet with it, and it has completed something like 20 full circuits since it formed. Every star in the neighbourhood is doing the same thing at slightly different speeds on slightly different paths. Over hundreds of millions of years, stellar neighbourhoods reshuffle completely. Stars that are distant now will drift past each other later, which changes the entire picture. A civilization would not need fast ships or extraordinary range. It would simply need patience, because the galaxy itself would keep delivering new neighbours within reach. Settlement would spread, not like an explosion, but like a stain in water carried partly by the movement of the stars themselves. I find that image quietly gorgeous, and I want to sit on it for a second. Nobody has to build anything extraordinary. Nobody has to break physics. A species simply has to be persistent, and the galaxy will do a substantial portion of the driving for them. Given enough time, the neighbourhood comes to you. And when the team ran that model, the galaxy filled up easily, even with slow ships, even with short ranges, even with settlements that eventually die out, which sharpens Fermi's question rather than softening it. If it is that easy, the silence is that much stranger. But then they added one more ingredient, and this is where the paper becomes something more than mathematics. They borrowed an idea from a novel published in 2015 by the writer Kim Stanley Robinson. In that book, a generation ship arrives at a planet after an enormous journey, and the planet is technically habitable, right temperature, liquid water, breathable in principle, and the settlers cannot make it work anyway. The details are the author's invention, but the principle is entirely plausible, and one of the researchers gave it a name. the aurora effect. The idea that a world can be habitable without being settleable, that a place can pass every test we would run from a distance, and still for reasons only discoverable by arriving fail to sustain anyone who tries. When they folded that possibility into the model, along with the reality that civilizations do not last forever, the results opened up enormously. Instead of two extremes, an empty galaxy, or a crowded one, they found an enormous middle territory. Galaxies that are partly settled. Galaxies settled in patches with quiet regions persisting for vast stretches. And most interestingly for our purposes, galaxies where somebody may have passed through a long time ago and simply is not around anymore. Which brings us all the way back to where we began. Because if a civilization visited this solar system 300 million years ago and stayed for 50,000 years and then departed or died out, what exactly would we expect to find? We spent the earlier part of this night establishing in some detail that this planet destroys its own records with remarkable efficiency. Ocean floor recycled, continents folded, whole billion-year chapters removed without a trace. The silence outside and the silence underneath turn out to be the same silence, and they may have the same explanation. Not that nothing happened, that nothing lasted. I want to be precise about what that does and does not mean because it would be easy to overstate it. Nobody is claiming visitors came here. What the modelling suggests is narrower and I think more interesting. It suggests that a galaxy in which somebody arrived and later vanished would look from where we sit tonight exactly like a galaxy in which nobody ever came at all. The two possibilities look identical from a bedroom window. And that is not a reason to believe either one. It is a reason to stop treating the quiet as an answer. Let yourself go soft here for a moment. None of this requires solving tonight, and none of it is your problem to carry. There is one more framework worth knowing about because it changes how the whole question feels. In the mid-1990s, an economist proposed a simple and rather brutal way of thinking about all this. Somewhere along the road from lifeless chemistry to a galaxy-spanning civilization, he argued there must be at least one step that is extraordinarily difficult. Something almost nothing gets past. He called it the Great Filter. The unsettling part is not the idea itself. It is that the filter has to be somewhere and there are only two options. It might be behind us. Perhaps the origin of life is nearly impossible. Perhaps the jump from simple cells to complex ones, which on this planet took something like 2 billion years, almost never happens. If the filter is in our past, then we are astonishingly lucky and the future is wide open. That 2 billion year figure deserves a moment actually because it is one of the stranger facts in biology. Simple cells appeared on this planet quite early within a few 100 million years of conditions becoming survivable. And then for roughly the next 2,000 million years essentially nothing further happened. No complex cells, no multicellular anything. An entire planet covered in microbes running in place for a stretch of time longer than the entire history of animals. Whatever finally broke that deadlock may have been a fluke of staggering rarity. Or it may have been ordinary. Nobody knows, and one sample is not enough to tell. Or the filter might be ahead of us. Perhaps getting to where we are now is comparatively easy, and what is hard is surviving the next few centuries after a species learns to reshape its own planet. If that is the case, then the silence we hear is not emptiness. It is the sound of everyone who came before hitting the same wall. And here is the twist that I find truly disorienting in the best way. If we ever discover an independent origin of life elsewhere in this solar system, even something microbial, that would be considered by many researchers to be bad news, because it would suggest life is easy, which would push the filter forward toward us. I am not sure I fully accept that reasoning, but I cannot find the flaw in it either, and I have tried. So let me hand the question to you, because I suspect your instinct is as good as mine here. When you consider that silence, the one that has been sitting over this planet for its entire history, what does your gut tell you? It means that we are early, that we are alone, or that plenty of others came and went and the universe simply does not keep receipts. I have moved between all three positions at different times in my life, which probably tells you something about how weak the evidence is in every direction. What I have settled on, if you can call it settling, is that the honest answer is simply that the sample size is 1. We have one planet, one biosphere, one civilization to study, and building a theory of the universe out of a single case is exactly the sort of thing that has embarrassed clever people for centuries. There is one last thought I want to offer here, and it is the one that reframes the whole night for me. The scientists we have been following have made an argument in various places that I think deserves more attention than it gets. A civilization is not simply a thing that happens on a planet. It is a thing that happens to a planet. Any species that starts harvesting energy at a global scale is by definition going to alter the system it depends on. That is not a moral failing. That is thermodynamics, which suggests that what our own species is experiencing right now, this awkward, dangerous, argumentative stretch where we are powerful enough to change the climate and not yet organized enough to manage, it might not be a uniquely human failure at all. It might be a standard developmental stage. Something every technological species runs into on every world the moment it gets good at burning things. If that is true, then the question is not whether a civilization causes a crisis. All of them would. The question is only whether any of them get through it. And that recasts the silence entirely. It stops being a verdict and becomes an open question about a test that everybody everywhere has to sit. I find something steadying in that framing, and I've thought about why. Perhaps it is because it removes the sense of uniqueness that makes our current situation feel so unbearable. We're not the first species in the universe to have made a mess of something. We're simply the first one we happen to know about on a planet where the previous attempts, if there were any left, nothing behind to compare ourselves against. Which brings us finally back to the ground beneath you, back to the layer being formed right now under the room you're lying in, and the very strange position we occupy as the only species we know of that has ever thought to ask whether it was the first. There is a way of holding all of this that is not frightening at all, and I would like to spend our last stretch together getting there. So let us come back at last to the place we started, which is to say to you, and to the ground underneath the room you are in right now, somewhere below the floor beneath you, past the foundation, past the topsoil, past whatever fill was dumped there when this building went up. There is rock. It has been there a very long time. It was there before this country existed, before agriculture, before anything resembling a human being stood upright anywhere on this planet. It has been quietly accumulating layer over layer for longer than the mind is built to hold, and somewhere in that stack, thin as a coat of paint, is the layer we are making now. I have been thinking about that layer all night and about how ordinary it is being made. Nobody is building it deliberately. It is being assembled out of receipts and dinners and commutes and packaging by 8 billion people who are mostly just trying to get through the week. The most consequential geological deposit in 66 million years is being laid down absent-mindedly by people thinking about entirely other things. That was the promise I made at the beginning of this night, that we would eventually turn the question toward you. So here it is, as plainly as I can put it. We do not know whether we are the first. That is the honest answer, and I want to hand it to you without dressing it up. After everything we have walked through, the drilled cores and the missing billion years and the frozen chemistry of a Roman workshop, the answer is not yes, and it is not no. It is that the question is legitimate, the evidence is absent, and the absence proves considerably less than we would like. There is no evidence whatsoever that an industrial civilization existed on this planet before us. None. Both scientists who proposed the idea have said so directly and repeatedly, and I have tried to be equally clear every time it came up. It is worth pausing on how rare that is. We have spent this night with an idea that could have been sold 100 different ways, and the people who came up with it chose every single time to say plainly that they had found nothing. No hedging, no leaving the door ajar to keep the mystery alive. Simply, here is a question, here is how you would test it. And no, we have not found anything. But their paper accomplished something that a simple answer never could. It measured the size of our own blind spot. It took a vague late-night sort of wondering and turned it into a set of specific measurements somebody could actually go and take. And in doing so, it quietly demonstrated that our confidence about the deep past has been resting on far less than we assumed. That, I think, is the real gift of the whole exercise. Not a lost empire, a corrected sense of how much we know. And there is a second gift folded inside the first, which took me a while to notice. Every method those scientists propose for detecting a vanished civilization turns out to be a method for detecting ourselves. The isotope work, the sediment chemistry, the search for signals that move faster than geology allows. All of it was developed to study our own situation, and all of it got sharper because somebody asked a question about the deep past. We went looking for strangers and came back with better instruments for looking at us. That happens more often in science than people realize. Somebody chases a wild idea, finds nothing, and along the way builds a tool that turns out to matter enormously for something else entirely. The wild idea earns its place not by being right, but by being pursued carefully. Now, before we say goodnight, I want to tell you about one more thing, because it is the counterweight to everything we have discussed. And it is the only story in this entire night in which somebody did the opposite of forgetting. In the summer of 1977, a pair of spacecraft left this planet launched a couple of weeks apart from a coastal launch site in Florida. Their assignment was to study the outer planets, which they did brilliantly. But a small committee chaired by an astronomer some of you will remember meeting earlier tonight as a 27-year-old, sitting quietly at the back of a chalkboard meeting in West Virginia, had been given a strange side project. They were asked to decide what should be attached to the outside of the spacecraft in case anybody ever found it. What they made was a phonograph record, a physical disc about the size of a dinner plate plated in gold. Onto it they pressed 115 images and the sounds of this world. Surf, thunder, rain, a breeze moving through trees, birds' wails, crickets, a heartbeat, footsteps, laughter. 90 minutes of music from across the entire planet, chosen with a great deal of arguing. Greetings spoken in dozens of languages, many of them by people who simply happened to be near the university at the time. And one thing more which I've never been able to think about without a lump in my throat. One of the people on that committee, a young writer who had recently and rather suddenly fallen in love with the astronomer running. It sat in a laboratory with electrodes attached to her, while a machine recorded the electrical activity of her nervous system for an hour. She spent that hour thinking deliberately about the history of our species, about the problems we cause ourselves, and about what it feels like to be newly in love. That recording's on the disk, somewhere out there right now, past the edge of everything our sun can hold on to. There is an hour of one person's brain activity while she thought about loving somebody sealed in gold, travelling outward at 17 kilometers per second. Nobody will ever decode it. Almost certainly not. We do not know how to interpret that kind of signal from another person on this planet, let alone how a stranger from elsewhere might. The committee knew that perfectly well, and included it anyway, which tells you the disk was never really an act of communication. It was an act of hope dressed up as engineering. The cover of the disk carries instructions etched in diagrams explaining how to play it. It carries a map showing the location of our star drawn using the positions of pulsars, which are essentially cosmic lighthouses that tick at fixed and identifiable rates. And it carries a small patch of an extremely pure radioactive metal with a half-life of about 4.5 billion years, so that anyone who finds it can measure how much has decayed and work out exactly how long it has been travelling. That last detail is the one that undoes me. They included a clock. They knew nobody would find it for an unimaginable stretch of time, and they wanted whoever did to know how late they were. Interstellar space is nearly empty. There is essentially nothing out there to wear the disk down. Current estimates suggest it could remain readable for something on the order of 1 billion years. Sit with the contrast for a second, because it is the whole night in a single comparison. Everything our species has ever built on this planet is being ground down, buried, folded, and erased on a world that has never once kept a complete record of anything. And meanwhile, two small machines are carrying a gold disc through the dark in perfect condition, likely to outlast the continents. The most durable thing our civilization has ever made was made on purpose by a committee in about a year, specifically, so that somebody who is not us would one day know we had been here. There is one more piece to that story, and then I will let you sleep. In 1990, more than a decade after launch with its main assignment finished, and the outer planets far behind it, one of those two spacecraft was asked to do something that had no scientific value at all. The astronomer who had chaired the record committee had been pushing for it for years against considerable resistance because the maneuver used fuel and risked damaging the instruments. The spacecraft turned around and photographed the place it had come from. At that distance, roughly 6 billion kilometers out, Earth occupied less than a single pixel. A pale dot caught by chance in a band of scattered sunlight. You cannot see anything on it. There are no continents, no oceans, no clouds. There is nothing to identify. It is simply a speck slightly brighter than the darkness around it. And on that speck at that moment was every human being who had ever drawn breath, every war ever fought, every language ever spoken, every love affair, every argument, every childhood, every grave. All of it contained in something smaller than a period at the end of a sentence. I bring that up not to make you feel insignificant. I bring it up because I think it is the perfect answer to the question we have been carrying all night. Because here is what strikes me, having spent this whole evening among vanished chapters and erased records on a planet that forgets almost everything. We are the only thing we know of that ever bothered to look. Whatever came before us, if anything did, we cannot say. But we can say this with complete confidence. On this planet, at this moment, there exists a species that dug into rock to find out what happened before it arrived. That built machines to melt ancient ice and count the atoms inside it. That drilled through the floor of a freezing sea to recover mud older than mammals. That sent instruments to another world, and then, having done everything useful, turned one of them around to take a photograph of home for no reason, except that somebody wanted to see it. That is not nothing. That may in fact be the most remarkable thing about us. Think about how strange that behavior is if you step back far enough. Nothing about curiosity is necessary. No creature needs to know what the world looked like 60 million years before it was born. There is no advantage in it, no meal at the end of it, no threat it protects against. It is from a purely practical standpoint, completely pointless thing for an animal to do. And we do it anyway. We fund it. We build enormous expensive machines for it. We spend entire working careers on questions whose answers will not change a single thing about how anybody eats or sleeps. A woman spends 30 years measuring chicken bones. A man spends his life splitting open tubes of Antarctic mud. Somebody argues about fungi for a decade and gets it wrong, and somebody else comes along and corrects them. The question of whether we are the first turns out to matter far less than the fact that we are the ones asking. So here is what I would leave you with as this long night settles toward its end. The ground beneath you does not remember much. Neither does the sky. Almost everything that has ever happened on this world has already been lost, and almost everything that happens from here will be lost too, including eventually all of this. That is simply the arrangement. But somewhere in the middle of all that forgetting for a brief and improbable stretch, there are creatures who remember on purpose, who write things down, who dig and measure and argue and correct each other and pass what they learn along to people they will never meet. That habit is the only thing standing between us and the same silence that swallowed whatever came before, if anything came before at all. And the fact that you spent your evening listening to a story about deep time instead of 100 easier things you could have done means you are part of that habit too, which I do not think is a small thing at all. I mean that, by the way, not as a compliment tacked onto the end of a story. Curiosity is not a personality trait some people happen to have. It is practice, and it survives only because individual people keep choosing it one quiet evening at a time, usually for no particular reason. You did that tonight. Somebody drilling into Antarctic mud did it too. It is the same behavior at different scales. Thank you for spending this time with me. Thank you for your patience with the long detours, the chemistry, the fungi, the arguing geologists. Thank you for letting a strange question sit with you for a few hours without demanding that it resolve. If you drifted off somewhere in the middle and are hearing this in the morning, that is perfect, and I mean that sincerely. This was never meant to be finished in one sitting. And if you're still here awake in the dark, I hope the last thing you take with you into sleep is not the emptiness of all that missing time, but the fact that somebody somewhere is still down there with a drill and a very patient expression trying to find out. There will be another story soon. Another quiet evening, another corner of the past worth sitting inside for a while. I hope you will come back for it. Until then, be gentle with yourself. Let the day go. Whatever is unresolved will still be there in the morning, and it will be smaller than it feels right now. Sleep well, my friend, sleep deeply, and if you happen to wake in the night and glance out at the moon, remember that it has been watching this whole planet since before anything here could look back. It kept everything. Good night.